vulnerable situations in the borders, and at all very bad conditions that we can name. And it's very important for us to take care of the metabolic rate, because they can have metabolic fatigue, and they can have hypo and hyperthermia, or they will be under severe psychological stresses, or they will be exposed to the toxic materials, and there could be vigilance lapses because they're human beings and they're extremely tired, etc., etc. So if you look at these four situations of providing medical emergencies or addressing the healthcare problems in the rural areas, and then when you have to monitor patients who have to go on with their regular life, they can't sit at home or in a hospital to just only for the purpose of taking care of their health. They have to go on about their own business. And then about the soldiers who are at very, very vulnerable places. And then again, during situations like the pandemic situations, or even in the post-pandemic situations, friends, so it's impossible for the doctors to provide that love and care to the particular patients. And in all these and even similar situations, the health parameters are to be measured and monitored remotely, and they should be transmitted to very nearby possible service stations like hospitals or police stations or any freelance service centers, etc., etc., to give them good health care. So in the previous slide, I just defined what is healthcare all about. And in this slide, I just depicted some simple 5 cases or the situations in which it's very difficult to provide healthcare, but we have to provide healthcare. So the only way out is to monitor the health from remote places as accurately as you can, and then transmit the data to a nearby station where some primary care could be given. For example, the army camps will have some local hospitals there, probably in a radius of 5 to 10 kilometers, wherein he can be shifted or addressed, etc., etc. So that is still possible, but that is a very, very important requirement in the background of the scenarios that I have just explained. Now, what are the ways to implement the solutions for remote monitoring and providing healthcare services are to use what are called as smart wearable sensors, which will have integrated transmitters. For example, I myself is a diabetic patient. So if I can wear a device that can continuously monitor my glucose and then send the data to my diabetician, I'm better monitored than suddenly going to a doctor in case of an emergency, right? Or if I come across an emergency, there could be some devices that will alarm the doctor or my caretaker, so that my health will be addressed. And that is the first solution. So then what I'll do is I'll have, say, 10 wearable sensors on my body. Then I'll connect them together to form what is called as a wireless body area network, in which there will be a network of the sensors on my body, and there will be a central local processing unit which will assess my health on a continuous basis and then go about giving the health care. This is extremely important for the soldiers. On their jackets, we can, include some 10 to 12 different kinds of sensors, which will continuously monitor their physical and psychological health and all the stresses, and then try to take care of, their health. Then going one step above, I can put all the things connected in my body to an Internet of Things. So that will become a medical Internet of Things. So medical IoT, MIoT is a special case of Internet of Things, wherein things are connected each other. They can communicate better. And by the end of the session today, you will really appreciate the kind of impact the wireless bands and the medical IoTs have been able to make on the healthcare of the people. This is what the main focus of my talk will be today. But because I have biochips also embedded into the title somehow, so the second part of that I'll be talking about biochips, which are nothing but multiple biosensors, which will have some integrated electronics, again thanks to VLSI, to detect multiple analytes in a particular sample, and they can communicate the measured value. So the line of differentiation is quite thinning down, but the purposes are different. So this is mostly like a lab on a chip in which you can measure multiple things offline, and this is more of a thing that the patient can wear and more about doing online. But these two together will make a very, very powerful combination, using which we can provide an extremely good kind of a healthcare for the people to whom we are adopting this particular technology, right? And my presentation will happen in this particular sequence today. I'll talk about the smart wearable sensors, and then move on to what W bands are and medical IoTs are there. So then the kind of impact they have made on the healthcare. Then towards the end of the talk, maybe for 10-15 minutes, I'll also talk a little about the biochips for the sake of continuity, to justify the title I have given to this particular talk. So let me go about. Hope you're all with me and tuned to me. The first is a smart wearable sensor. We know what a sensor does. So sensor is typically convert one form of energy into another more usable form of energy. like what we have seen, but can I wear it and move around? For example, when I go to the doctor, he can always put a thermometer and measure what is my temperature. But it's inconvenience for me to go to the doctor every time. So if I can have some device embedded onto my body in which all my parameters are continuously monitored, so that becomes a wearable sensor. So to define what is it all about, wearable sensing technology is a category of devices owned by the subjects. Here in medical domain, when I say subject, it's a person or the patient that allow continuous physiological monitoring with reduced manual intervention and at low cost. I don't have to go to a special hospital spending tens of thousands of rupees for my diagnosis, but I can be on a normal life sitting in my office or going about my daily routine. But I'll be wearing some 8 to 10 different sensors which will keep sensing my parameters and then communicate to a nearby device. To give an example, so just let us look at this particular subject. We can monitor all the physiological biosignals and sensors, like we can measure the pressure, the motion, or the tactile sensor, or the vibration he's going and undergoing. Then we can even pick the thermal signal, like the fever and hypothermia. And we can even measure using wearable sensors the so-called electrophysiological signals like the brain wave or the EEG. Then we can monitor the cardiac activities. Then we can even measure the muscle movement using EMG sensors. And you can see him wearing a smart band. So this smart band is a fellow that will be embedded with tens of sensors that are able to measure the parameters and communicate to a local device. And you can wear a textile like a thing as a thermometer that can measure the skin temperature, or you can as an EMG sensor, EEG sensor to monitor the brain waves, and you can wear a smart textile, and then you can wear a smart watch. I mean, hope you are able to appreciate the kind of devices that the person is wearing, and all of them will be able to communicate to a wireless communication network through the router, through the internet, or to a local unit, etc. And then that can go to a remote medical service, so wherein either self-diagnosis is possible, or even home healthcare can be given, and the feedback is also given back to the patient so that he can adjust himself to measure to maintain better health care. So that's what is wearable sensors all about. So they are the sensors that we wear and go about our life, and our health being monitored continuously with very, very less or minimal manual intervention, and very affordable devices is what we get. And it's very important to notice that all the principles or techniques that we use for these sensors will be non-invasive in nature. Invasive is a process in which we pierce a needle into the body of the patient, usually to draw a serum or the blood sample and then go about. That's what typically happens to us when you go to a diagnostic center. But here we can't do that. So usually 99% of the wearable sensing technologies are non-invasive in nature. I mean, it is something that you can wear it on your body. In some cases, that is inserted into the body of the human being, but not every time. Once in a while, for example. I can wear an ICD, which is the artificial pacemaker embedded into my body. That is also a kind of a category, but you don't invase every time that you want to do it. So all the smart wearable sensors will be non-invasive in nature, but in some cases they'll be very, very minimally invasive. I'll show an example, maybe some time, wherein the invasion is very, very less using nano kind of a technology. So therefore, that's the property of these wearable sensors. Now, exaggerating it further, these are the typical body positions on which we deploy the wearable sensors on the head to monitor the EEG signals, or on the chest, or on the arms, or the shoulders, then at the armpits, and then at the knees, and then on the belly, and then on the foot. So these are the typical positions where we will have predominant kind of a biomedical signals available for us to monitor his health conditions. These are the typical body positions where you fix it. Then we can have different type of sensors. You see, after all, it's a sensor. So all the basic sensors of principles of sensors can also be logically extended to these wearable sensors. So we can have biopotential sensors like the EEG caps. You can wear a cap and his brainwave is monitored, but very, very minimally invasive or not at all invasive. Then EMG bands to know the muscle activities, or ECG chest straps to know the cardiac activities. And we can have optical sensor in the form of glasses or contact lenses, or even a camera that you can't see and he's not at a discomfort. So that's the way you'll be wearing a device. And we can use stretch and pressure sensors like textiles and belts, and even chemical sensors like the electronic skin or the textile that you can vary. and even inertial measurement units like wristbands, smart patches, and body fixed sensors are the typical sensor types what we use under the category of the wearable sensors. So I told you about the typical body positions on which we fix the wearable sensors, and kinds of wearable sensors that are deployed as on today worldwide and usually adopted. And then when it comes to the applications of these wearable sensors, they can be deployed either for the purpose of wellness, in which we monitor the activity and fitness of a particular patient, or to provide safety to the elderly people, like for example fall detection or seizure detection or even cardiac arrest detection. So I can wear a sensor on my body which will detect me falling down, or me having a brain seizure, or me having a cardiac problem. So I can use it for the purpose of safety, or I don't have any emergency, I'm quite normal, but my wellness can be monitored continuously. For that also I can use wearable sensors. Or for rehabilitation purpose, if somebody meets an accident and he will undergo severe surgeries and he will go back his home, and the physiotherapist has assigned some kind of a therapeutic exercise for him, but we can't expect the expert to go to his home and monitor his progress. So from a remote place, if he's asked to do some exercises, the doctor can as well monitor his rehabilitation procedures and correct him. And we can further go to the extent of incorporating some artificial intelligence algorithm wherein there will be self diagnosis, and is guided at home itself about the way he has to correct his movements, and become better at the earliest possible. Then also to know the application could be for disease management, to know the treatment efficacy or the disease progression. For example, if somebody has corona and is in an isolated place, so doctor would like to know the progress of the disease. Is he curing, or is he going to severe cases? Number one. Or if he's given some medications, they want to study the efficiency of the medication. Should I increase the dose or reduce the dose, etc., etc. So please remember, we are using wearable sensors in all situations wherein it's not feasible for the doctor to be in the very close physical vicinity of the patient for various reasons or applications I told. So therefore we can use wearable sensors to manage the diseases also, and even to predict diseases, and make an early detection. For example, monitoring of early signs. For example, could be the golden hour detection of a cardiac patient, or some very low seizure detection that can lead to catastrophic failures. All such things can be easily detected. Yeah. So in this slide, I told about the typical body positions and the typical body sensors that can be deployed, and what are the typical applications which can be broadly classified into 5 areas as wellness, safety, rehabilitation, and disease management, and also disease production and early detection. Now, we know what sensors are. Now, these are wearable sensors. So the wearable sensors, like the one depicted in the picture here, which is a smart watch, which is monitoring blood oxygen, it should have some certain typical features, like it can be worn on the human body. If you give me a device that weighs 4 kgs but can do fantastic things, but it is at my discomfort, I don't want to use it. So when we take up designs of wearable sensors, we should see that the person can easily wear them on his body, and they should not be invasive in nature, and it should not discomfort the patient. So that's very important. That's the reason why people came with the idea of a smartwatch, which we love to vary, but in addition to showing the time, probably it is doing a lot of other wonderful things. It may not show the time also, but it will do my health monitoring. And they should be flexible, because our body is flexible. I'll show some pictures later. The wearable sensor is also expected to be very flexible, in its operation. And wearable sensors will typically diagnose a health condition, and they support safe, comfortable, and healthy living of the subjects. And it can determine the patient's metabolic state from a remote place. And it's obvious that these wearable sensors will redefine the doctor-patient relationship. When I say doctor-patient relationship, we know what the relations used to be, say 15, 20 years before, but during corona all of us did a lot of online consultation. So the very situation led us to redefining the doctor patient relationship. Nowadays the patients are well informed, and they have to be self-educated, and also they will know some basic steps to be taken care of, etc. We've seen a lot of diabetic patients who can inject insulin into their body on their own, which is an extremely difficult thing, right? So as the need of healthcare is getting changed, people are also getting educated about deploying all these devices. So this is what typically wearable sensors will do for us. So if you look at this particular thing, so it could be a sensor that can be easily attached to my palm, and as I move it, it should become an integral part of my arm. and they should be able to still move it. So therefore, they need to be flexible. Look at this with this, some kind of a sensor, graphene base, that is wearing at the fingertips, is able to pick a ball. I mean, that's so flexible. Please remember, I have told you time and again, wearing wearable sensor should not, disturb him from doing his normal activities or life. So therefore, they are required to be flexible. And this is some kind of a sensor where he's wearing a belt, and you can see, various parameters that are measured using some electrochemical sensors, and they're communicated a smart device wherein, he can monitor the pH and the chlorine or the sodium, and all the things. And look at this. This is kind of a micro array which will pick the sweat from his particular body, and that goes to two chemical reactions here and various vitals monitored, right? Hope you're getting a feel of what wearable sensors are all and the kind of impact they can make on our healthcare. And to amaze you, let me list the typical parameters and salts that people have been able to measure very successfully. So we have been able to measure the pulse rate, the oxygen saturation level, then respiration monitoring, then the hand gesture recognition, then the acceleration and inertial sensors, and blood pressure, body temperature. These are some of the few parameters I have listed, but it could be beyond that also. So it's a data that I have taken from my friend's textbook that was published in 2017. By 22, probably we'll have another 4 or 5 parameters. So typically, what you can measure in a diagnostic center or an hospital can also be measured using these wearable sensors. And look at the kind of sorts that you can measure. Using all these sensors, we're able to measure calcium, sodium, potassium, chlorides, lactate content, then the creatinine, cholesterol, urea, uric acid, oxalate, triglycerides, ascorbic acid, and whatnot. Typically, what a diagnostic center will give, we can give all these signatures using wearable sensor technology, thanks to the ability to miniaturize the sensor concepts and the integrated electronics and signal processing that is possible on the particular device itself. And invariably, whatever you measure, we also measure the body temperature, because body temperature will indicate, will give a, a kind of signature of the whole patient. That's the reason why, whatever be the problem that we suffer from when you go to a doctor, they will first measure our fever, then they will also measure our blood pressure. So these are the two very vital signals that will have a lot of stories to tell to the particular doctor. So invariably, we also employ some kind of a temperature measurement on the human skin, which will provide a lot of useful information on health condition. Could be stroke, heart attack, shock, lung disease, infections, and on and so forth. So we will have sensors to measure all these, physical parameters, or it could be one level below to measure all the ionics and salts, which will have stories to tell about the health condition. And also we will add on a temperature measuring device, because as I told you, that is a very vital signal that will tell about that will have link to your other problems. For example, when you have indigestion, you will get fever. When you have something else, you will have fever. So we measure fever at the first level, then go to the other levels of making measurements. Yeah. And I just mentioned that to deploy wearable sensors, we would like to employ a non-invasive technology. I mean to say, the body-worn sensors on the surface of the body will not be drawing blood from the human beings, or at most they can be very, very minimally invasive to make this. So it means that indirectly we cannot, or we don't want to use blood as the sample to make all this measurement, which is one of the normally used liquid to make all the diagnosis. But here we use what are called as the body fluids, like saliva, tears, sweat, and the skin interstitial fluid to make measurements on the human body. So wherever possible, we will have a body-worn device. But what is the analyte that we will measure will be from the saliva, what we produce in the mouth, and the tears, and the sweat, and the SAF liquids. So just to give a glimpse of the kind of sensor that people have developed, look at this mouth guard. I can put it in my mouth and it will continuously monitor my uric acid. Or you can have a graphene based tooth sensor that is able to detect the bacteria. Or I can have a microfluidic sensor on the arm, which will measure my lactate and glucose, which is very important for diabetic patients. Or I can use a nanomaterial based patch sensor to measure glucose. Or you can use, iontophoretic patch sensor again to measure glucose, or you can have some kind of a textile-based biosensor to measure lactate, or this could be used to measure his pressure, and I can even measure cortisol, IL-6 using wearable sensors, and you can have an integrated sensor array around his wrist, and you can measure lactate and glucose, or you can have chemical and physical hybrid sensor to measure lactate and ECG, and you can have a smart contact lens, which can also measure glucose from your tear. I mean, that's how technology has been deployed to develop these very novel and innovative biomedical sensors using wearable sensing technology. Let me spend some 10 minutes or so to talk about the nature of these body fluids that I just mentioned: saliva, tear, sweat, and SAF, ISF, using which we make all this measurement. Saliva is a very complex fluid of numerous chemical species permeating from the blood. So the saliva typically will have a lot of species that are permeated from the blood, and they carry many vital physiological parameters. And we know, saliva is easily available and does not require any treatment step for testing. It is always fresh in the mouth, and you can catch hold of little saliva and go about testing. And you can directly use a sample. That is, there is no chance of contamination, because God has given that ability to continuously, generate this saliva, and saliva could be an excellent, fluid as an external body fluid to make wearable sensors that can measure a lot of things. And the biochemical species present in saliva typically provide the online condition monitoring of the emotional state, the hormonal state, the nutritional state, the metabolic conditions, or the pH level, or the fluoride acidity, and so on and so forth. Right? Of course, there are some procedures that you should not have consumed anything hot or a coffee or a tea before giving the sample. That is there for all conditions, for that matter. But however, your saliva can provide all this very vital information about a particular subject to himself and to the doctor as well. Look at this particular example in which they have developed a sensitive and a non-invasive cholesterol determination in saliva. So a drop of saliva will go here, and this is some polymer based, some kind of a sensor. Let me not go to the details again. You probably will get a feel of. I can quote this example when I talk about the biosensors towards the end of this presentation. So there will be some kind of an electrochemical reaction between the saliva and the enzyme that is already present here in the form of a bioreceptor, and it will give some kind of a signal using which probably they're able to determine what is the cholesterol in this particular patient. Then the second example I can give is a mouthguard based wearable salivary uric acid biosensing platform with integrated wireless electronics and analysis of salivary uric acid concentration. So you can see this is a mouthguard that I can put into my mouth, and there is a salivary uric acid biosensor that is present here, and there is a lot of wearable electronics that will be waterproof, and you can see different kind of salivary unit in micromoles. For a healthy person, it will be less than 250, but for a person with hyperuricemia, it will be around 750, right? So, I mean, this is a very vital signal to the doctor and the patient himself, so that he can alter his medication for the various purpose that I was trying to list, right? Yeah. So, friends, I told you about the first body fluid that used very widely to measure or to know the health condition of a person using saliva. And the second is a tear. Tear is what is produced by the eye, which will provide that protective layer on the eye. But please don't think I have to make somebody cry to generate this sample. So there is always a thin, film of tear fluid present on the eye, and that can be used to make, lots of measurements. So typically, if I look at the cross section of that, you will have cornea, so then mucin, aqueous, and lipid profile, then the air. So you will have a couple of layers here. And look at the concentrations of the tear fluid constituents. It will have around 120 to 165 millimoles of Na plus, then K plus, chlorine, magnesium, calcium, bicarbonate, urea, ascorbate, lactate, glucose, and the total protein will be 5 to 11 mg per milliliter. So our tear is filled with all these chemical components, as many as 10 to 12 of them. We will use a biosensor or a wearable sensor with that selectivity to measure what you want to measure. See, selectivity becomes a very, very important issue in biomedical sensors. Why? Because any component will have all these multiple things with himself, and you should be able to go and pinpick this particular point and discard the other things. So that's the issue of selectivity, which I'm not talking about in the presentation today, but here could be one very important thing. So we can place, very miniaturized and flexible thin wearable sensors on the retina here without discomforting the patient, of course. And you can measure all these important parameters without the need of any transport of the sample. You don't have to collect a tear sample and then send it elsewhere to do that. So we can place a sensor right on the retina, and you'll be able to monitor. And when I click the mouse next, you'll be amazed to see what all can be measured in the tear sample. So people have been successfully able to measure the health condition of the disease, like the allergic conjunctivitis, in which we'll get the red eyes and the red reddish thing around the eye. And they've successfully detected cancer in patients, then cystic fibrosis, then diabetic retinopathy, dry eye detection, glaucoma, then ocular allergies, then Sjogren's syndrome, which is the disorder of the immune system, then thyroid ophthalmopathy, and then herpes simplex virus. So, I mean, as many as 8 to 10 different conditions can be monitored using this particular TL sample. And I've taken this information from the contactless biosensors from the Sensors magazine. Probably the interested can go to that. I thank the authors, because I have taken data from them. So that is what we can make tier based sensors to measure a range of health conditions of the parameters in a particular patient. And to just to exemplify two tier-based glucose sensors, a company called as Novio Sense developed electrochemical tier glucose sensors. So from this, they were able to measure. They were able to put a spring-like device without discomforting the patient within the conjunctival fornix area shown here. That was able to continuously access the tier glucose. Then it had the integrated electrons to transmit the data somewhere. And then also, the contact lens was developed by Google and Novartis, are the two companies which were able to measure the glucose concentration in a miniature sensor like this. So you can see that it's a contact lens glucose sensor. It will just sit on a retina like a contact lens. Probably it can work as a lens also. Then it will have a tier glucose sensor. So then it will have a chip and an antenna. Again, thanks to the microfabrication technologies in the VLSI, so we have been able to embed, or join the VLSI and our sensing technology to achieve or accomplish all these wonderful measurements. Yeah. The third liquid is a sweat. Sweat is the body fluid which contains water and various electrolytes and the nitrogenous components and metabolites. And sweat, the problem is with the challenges of contamination, because it's on the skin surface and it will easily get contaminated with the dust and various other things which is already present on the skin surface, and the sweat will easily get evaporated. And it's very difficult to have real-time sweat sampling and sensors because it will just evaporate. And for the one and two reasons quoted here, so collecting the tests, sweat sample is not very easy. But not. In spite of all this, people have been able to do in situ sweat analysis, in which they'll put a sensor on the surface itself, and without the need of the transportation of the sample, and before it evaporates and before it gets really contaminated, and people have been able to measure. And various sensors are available today, the wearable sensors to be more specific, to measure the pH content, zinc, sodium lactate, ammonium, calcium, then cystic fibrosis parameters, and the physical stress level. Yeah, obviously. Then the glucose, osteoporosis, then even the bone mineral loss have been measured. Then skin fibrosis, then even the alcohol level can be measured. In drug abuse and all these cases, we can use this sweat-based sensor to see if somebody had consumed alcohol. Then even kidney failures can be detected using all these sensors. So these are some of the typical sensors. Let me not go to the details in the interest of time, but hope you can get a feel of these sensors that are put on the human skin, here or wherever. They will immediately take hold of the sample and have some quick electrochemical reaction happening to give you a measurable signal to know one of these parameter being measured, which the doctors will know what is it linked to, or you can develop an algorithm to find out what is the health problem of this particular patient. So sweat is the third liquid. And the fourth is the skin interstitial liquid, which is available, a couple of micrometers below the skin surface, below this, epidermis. So now, if I want to use a sensor, I can't use a totally non-invasive sensor, but I use a very, very, minimally invasive sensor. And this liquid will contain a lot of information about the sugar levels, the salts, the fatty acids, the amino acids, and even coenzymes, hormones, the neurotransmitters, white blood cells, and all this. So therefore, for the detection of sugar levels or even the organ failures or the drug efficacy, the excellency with which the drug is working on the human body, or to detect any salt, we can make this measurement. So as I told you, because we have to draw the SIF from this, so we can use this nano indented rods. Probably the height of that will be few nanometers or whatever. So when you tightly wear it around your wrist, they will not really pierce the body. So, but by going with the definition, they are invasive, but not truly invasive. So we call it as minimally invasive sensors. So this could be one kind of sensors, right? Yeah. So friends, I defined what is wearable sensor technology all about. Then I threw some light about the body positions and the typical sensors that are used and the 5 different health related applications for which they are measured. And then because we wanted to make them non-invasive, so obvious choice is to use the body fluids. And I told you what are the typical 4 body fluids that are extremely well used. Without using the blood sample, people have been able to measure all these vital parameters or various salts and physical parameters of the particular subjects. Now, having told you that we use one of these 4 body fluids or the combination of them to measure all this, but let me tell you, any wearable device that you develop may be less worthy of measuring all that you measure if you don't have a notion on what the human body is doing. I'm trying to tell you that the motion detection and profiling are very important whenever you apply wearable sensing technology. I'm trying to tell you that I may use a sweat sensor, I may use a saliva sensor, or I may use a glucose sensor, I may have a contact lens sensor. But it's also important to put on my body some kind of a sensor that will detect my motion, my profiling, what am I doing, how active I am, what is my physical activity, etc., etc. See, there is a difference between some bad cardiac signal when I'm able to speak and a cardiac signal when I'm unable to speak, right? So that should be detected using suitable sensors. So it's very important to measure human movement because we know that that is affected by the psychological, analytical, environmental, and social effects, and very abnormal physical and emotional conditions. So therefore, in addition to deploying all the variable sensors that you have deployed all this while, it's very important to identify any reduced or impaired movement and estimate the important parameters affecting the particular motion of the human being. So typically under the banner of wearable sensing technology, we invariably use what are called as accelerometer or the gyroscopes. Very smart devices are available using which we can measure vibration, shock, and temperature, and the rotation and acceleration or the jerk what we undergo and things like that, or the tilt. This is a tilt sensor. So if you, especially for patients at home who are staying all alone, we add a device like this in addition to whatever that you have employed, so that we add value, we add significance, or we made the whole diagnosis much more meaningful than just doing it with the 4 body sensors. So we employ these accelerometers and their counterparts to monitor the human body movement also. Let me give an example. To justify what I was trying to tell you. So it's a wearable instrument at West for posture monitoring. You can see, around 5 accelerometers have been put into this jacket. One near the lower cervical spine from behind. So then again one on the back lumbar section, and then on both sides of the waist, and then on the chest. So we add a lot of electronics to that, in which we put all these accelerometers with I2C output on the gateway and acquisition process. So then we can have some kind of a sensor module. So then we can have a low power microcontroller like an ARM Cortex M3, wherein we will have the sensors, power and internal communication, then the MCU, and then storage and external communication. So typically it's a very small embedded system, like an Arduino Nano or a very, very low profile device with a lot of these sensor modules that can be put on a single bus called as I2C, and make all these particular measurements, right? So a person can wear a jacket and go about his normal life. So this can be used either for during the rehabilitation purpose or for the elderly people whose health is to be taken care of. So if you just look at this is now connected to another device for the doctor to measure is a real-time data which is streamed out from the West, and a screen capture of the real-time interactive posture monitoring app. So the physiotherapist will be able to know the kind of movements he's taking and then make some corrections to him. So please appreciate. Instead of the patient going to the doctor is simultaneously connected to tens of his patients, right? Um, that's where the technology is taking us today, and he can detect the inadequate postures or his difficulties, so then give feedback to him, etc., etc., to monitor his health condition. So this is just one example to tell you how the wearable accelerometers can also be deployed for the purpose of posture monitoring, as demonstrated here. So then let me give a very fitting example of a wearable sensor that was developed in July 2020 by the Northwestern University and the Shirley Rayan Ability Lab, the researchers. They came out with the design and development of a wearable sensors, and also created algorithms to detect the early signs and symptoms of COVID-19, as well as monitor the patients as the illness progresses. So they will just put a device which is a very soft and flexible sensor, just below the notch in our throat, which is a visible dip here, and it measures coughing intensity and patterns, chest wall movements, respiratory sound, and heart rate and temperature. So a small device like this, which was developed by these people, is able to measure as many as 4 to 5 parameters, of course with a lot of signal processing, and the data could be connected to a smart device, maybe the patient's own mobile phone, wherein he can monitor himself and communicate to the doctor or take online consultation and so on and so forth. So these are some of the examples to highlight the extent to which people have been able to successfully develop these wearable devices. And we have tried to develop two very humble devices. I call them humble because we never made them as products, but out of the projects that my students did, we developed a PPG sensor at the pinna. This is a pinna of our earlobe, and we were able to make a device like this, using which we were able to measure the PPG sensor. And of course, our PPG sensor was very accurate, almost more than 90, 95, 99% of accuracy, and we can derive a lot of things from this particular PPG sensor. That was one of the wearable sensors that we have developed. And the second is a wearable and non-invasive cerebral oximeter. Pulse oximeter will measure your SpO2 at the fingertip, and it's very important to measure what is the oxygenation available on the cortex regions to the left side and right side, especially when somebody is in given with anesthesia, to monitor how it is progressing. Number one. Number two is to monitor the paralyzed patients whose left brain and right brain will not be coordinating, etc., etc. We know all those situations, so we can have this thing. So it usually uses the Beer-Lambert's law to measure the differentiation, absorption difference between the blood that is oxygen rich and the blood that is oxygen deficient, because it is Hb and SpO2. By taking the ratio and making 4 different measurements at for 2 different lambdas and 4 different times, we can measure what is the oxygenation levels. So we measured a very humble device. I mean, if you look at this particular device and contrast with the ones that were shown in the previous figures, so this, it's obvious that it is out of a student project, but we were able to measure the parameters. Of course, I have not shown all the electronics here or the algorithms here. Just to exemplify, we were able to measure the oxygenation level in the cerebral region, but way to go. It's a very simple device. Now, let me acknowledge my students who were able to do this particular project. Atit, my MTech student, developed this, and Neha and Vismaya, my undergrad students, developed something on the wearable non-invasive cerebral oximeter. So thanks to them, and I've quoted their work here. Yeah. I think I have spoken to you about enough about the wearable sensors. Now, how about connecting them together? I mean to say, I can have 10 different sensors in my body. Can I connect them together? If I connect them together, can I also connect them to the internet? It's very much possible. Of course, these are all electronics embedded. They'll be enabled with some kind of a communication technology using which you can still make it possible. So web-based network of smart medical devices effectively communicating with one another, and also with a central thing, with or without, as much as possible, without the direct human interactions, we were able to do all that. But lots of challenges, it's not easy to come out with new technologies. You have to have, address all these major challenges to ensure reliability, devices available at low cost, especially when you put a lot of devices together. What's the quality of service you can give? Then the scalability issue, and can it adapt himself to the existing network, or do you want a different kind of a network available? And once you go to the public domain, the most two important things will be the security and the privacy. How do you provide security and privacy for data? And then what is the efficiency? And is it a very low energy device? And so on and so forth. These are the challenges that will come along when you want to extend your wearable sensing technology into the form of a connected medical devices. But people have been reasonably successful in deploying them. So when I want to connect all these devices together, that becomes what is called as a wireless body area network. As you can see here, I have a wearable sensor for ECG, blood pressure, pulse oximetry, motion sensor, EMG, and then all they can talk to each other, and even they can talk to their mobile phone as a gateway node. So within this, it is called as an intraband. Beyond that, it becomes a wireless body area network wherein it can go to the base station, and it can go to the medical server where the data is stored, and it can also go to a medical expert who can give feedback to this. So friends, so now the patient is well connected to the doctor and he can be remotely monitored. So that was the objective, what I mentioned in my second slide, in which we want to provide very good healthcare to the people, even when the doctor is not physically around the particular patient. Let me go one step further. How about a medical IoT system? When I talk about IoT system, it's my duty to take the name of Kevin Ashton, who coined the phrase of the Internet of Things in the year 1999. He's the boss. But it took some 10 years to take off. But now, we have seen every student and every professor talking about Internet of Things, in addition to talking about artificial intelligence or machine learning or data science. So thanks to him. So this is how we can have an end-to-end IoT system. You can have sensors here, which are like this, which are based on the human body, and usually we use very powerful microcontroller like CC253. Just an example I'm giving, which is a system on a chip. Then it will have its own small operating system called as a Contiki OS. You can have other operating systems also. I'm not going to all the details here. I'm just giving an example of an end-to-end IoT system. Then it goes to the router, then it goes to another router, the data is routed to them, then it can goes to a base station, and it can use a gateway like an Intel Edison, or it could be something else also. Then I'll use a Mosquito, which is an open source message broker or a server to transfer data commands. So you will have a lot of PCs subscribed to this particular broker, wherein we do what is called as publish, subscribe, and kind of a concept. We use an MQTT protocol there to do all the communication. This is just end-to-end kind of a thing. Similarly, you can have hundreds of sensors now that are connected to this particular server, and this is where the expert is sitting, or the medical server is sitting, and you can see the patient here is well connected through all this technology to the patient who is sitting elsewhere. So with the exploration of medical IoT systems, we have been able to collect, record, and analyze huge volumes of patient data for preventive care, diagnosis, then assessing the treatment efficacy, and provide other valuable actionable insights to patients and doctors. See, actionable insight is very important. When I say actionable insight, it should be some kind of an information based on which the doctor is able to take an action. That's what is called as an actional. Usually, the doctor will take an action once the patient is physically examined. But despite that not possible, despite everything being reported, this sensing technology has proved its efficiency to be able to make the doctors give these actionable insights on the particular patients. And once I say IoT, we want things that are not physically connected. So obviously, we use a lot of wireless communication protocols here. I have just listed for the sake of comparison, like Zigbee, Bluetooth Low Energy, LoRa, Sigfox, Z-Wave. And typically what they do is the range will vary, the power will vary, the kind of topology or the network topology that you can use could be mesh star or cluster here or only star here, and so on and so forth. The data rates will vary, and the kind of modulation techniques will vary, and the radio frequencies will vary. This slide is just to give a glimpse of the kind of wireless communication technologies that are developed in combination with the wearable sensors, what I spoke to you about in the beginning, to get them married and have very good systems being developed and able to give better healthcare to the people. You can see some kind of a situation here wherein a lot of communication happens through wireless protocols. So based on the distance, based on other things, you can take a call on what is the best kind of a thing that you want to use it for your application. For example, look at this. Sigfox can go up to 50 kilometers. We call it as countryside kind of communication, in which if you want to send data to a very high distance, we can use a Sigfox as the communication protocol, right? Yeah. But I think I mentioned that once we talk about IoT or medical IoT, our data goes to the public domain. So the security of the data, privacy of the data become very, very important. For example, I just mentioned that I'm diabetic, right? So I don't want the world to know that I'm diabetic. And somebody may have some problem that no one else should know that, right? So security of your data, because See, in addition to good things, there will also be bad things coming up. There will be hackers who are criminals who can get into the network and play havoc with somebody's healthcare. They can give a wrong signal to an insulin injector. So instead of injecting 5 ml, if you inject 50 ml, the patient is gone, right? So a lot of threats will also come along with the particular kind of a security. So it's very important to provide security, especially with the proliferation of smart mobile devices. You can see that the IoT or the medical IoT is growing very, very exponentially. If you compare the world population, the connected device, you can look at this. It was just 500 million in 2003. By 2020, it became 50 billion kind of connected devices to the internet. And when I take an average, it was just 0.08 number of devices connected per person, but today it is 6.58 devices that are connected to a human being. You can imagine the rate at which it is exponentially growing. It's almost growing exponentially like this. But as I just mentioned, it will come with a lot of challenges to implement good medical IoT systems because of these things. One significant challenge is the provision of security, access control within the IoT, and identity management. Think of 100 people connected. I should know to whom I should give the access, to whom I should not give the access. I should know that this data belongs to X person on this date, then is present at this particular location today, tomorrow is in some other place. So the entire gamut of issues of a particular subject should be monitored. It leads to humongous amount of data. I'll tell you, humongous amount of data. So it's not a joke to carefully monitor all this, simultaneously providing security and ensuring privacy of the particular data. And how fresh is your data? If you don't time stamp it, the whole meaning is lost. If I tell you my HbA1c is this, the question is, when was that, right? So time stamping is very, very important. And another reason why it becomes even more challenging is the high mobility of things. It is Internet of Things. Things are physical devices that can move around, right? And they can be, high mobility. And the scale of the system, there is no one to monitor how many devices are connected to a system. Today it could be 100, tomorrow it could be 1,000, next day it can drop out to 500. So it is highly scalable and vulnerable. And different people will use different kind of network topology, and they can use different wireless communication mediums, and the kind of devices that they use could be very heterogeneous, and they can use different software platforms together. In addition to this, the entire real world is very, very, very wide. Different spectrum of people, different kind of health condition, different ethical issues from country to country. But if you want to put all of them together on one cloud, it becomes even more challenging. So therefore, security is very, very important to be provided, though it is very challenging to do that. And these challenges are further worsened by factors like the device limitations. We will have a wearable sensor with a low power microcontroller like the CC2205 told, or a small some other device. So it will have limited memory, the battery life is limited, and its processing capability is limited. But we want to provide security. When I say it argues against the use of heavyweight security, see, if you look at these parameters, obviously you cannot give very heavyweight security. But we want to give heavyweight security. So that's the very biggest challenge, in which you have to compromise between the memory, the battery size, or the features of a particular device, and also provide not heavyweight, but not very low weight kind of a security. So if you look at these two examples of this, your wallet, and this is what you have put in the bank. So this is highly secured. But now the question is, can I provide that kind of a security to my wallet? I can't, because it's a small wallet I'm carrying. But I need to provide that security given the importance of the particular data. So it's very conflicting requirements for you to provide the data. Somehow you have to compromise on all the resources and ensure that you will provide good security to the devices. And we'll have numerous transient relationship. Relations will make and break because of the mobility of the devices. For example, the way you will move your mobile freely, but you never know to which tower is your mobile connected. So there has to be a network manager to manage all these things, right? The same thing if it is logically extended. So it's very difficult to maintain good transient relationship. And again, issues with identity, both for the users and the things, and then access to the services. And with the kind of devices that are connected per person, as I just mentioned, it's very, very challenging to provide a good security to the data that we provide, but people have been able to do that. And in addition to that, you have to have users identification information and confidential health information, and it should be contextual information. We should tell about where is the location, what is the date, what is the time, and so on and so forth. So it's an extremely complex thing to implement medical IoT system, but it is getting matured and people have been able to deploy all these devices. So typically, this has been able to give a lot of impact on these areas, like continuous clinical care at remote places. You're able to measure, and you can monitor patients remotely, and you can ensure that whether people have adhered to their medication or not. Then you can have early preventions, and then a lot of wellness programs are going on, and obviously they have defined the doctor and patient relationships. And the advantages are improvements in the patient outcomes, reduction in errors because there are no human to play, induce human errors. Anything automated will obviously perform better than us because we are subjected to a lot of human errors being added, and able to manage disease in a better way at very lower cost and enhance patient outcome. And this is a beauty. You can do a lot of data analysis, which is not possible in our convention. See, the moment the data becomes digital, you can do any kind of analysis with that, and even you can provide real-time assistance to that. And but concerns are as follows. I have to say this: the IoT can't replace the human touch. So finally, we go to the doctor. So therefore, all that I spoke about today is only complementary and cannot replace the conventional established techniques. But one step before, they're able to make our healthcare better. As the need arises, I have to still go to the doctor, get myself hospitalized, and things like that. Then I told you that what is very challenging is the data privacy and protection. So there could be hackers coming into your play. They can do either passive hacking, active hacking, and all that. We implement a lot of hash algorithms to provide security. That's a different domain altogether. So then the cyber securities are very genuine concerns, and differences in state regulations in telehealth care. Implementation difficulties. See, our state will have one regulation, the neighboring state will have different regulations. So there should be some federations which will sit together and come out with some common rules to do all this. Yeah. So with this, I'm done with my presentation, wearable sensors, but I have to talk about biochips. Madam, I have touched 11. Can I go for another 5-6 minutes and complete this topic also?
Yes, sir. Yes, sir. Sure, sir.
Yeah, yeah. So please bear with me. So let me talk about biochips now. What are biochips? To understand what biochips are, we should know what biosensors are. So let me spend 5 minutes to talk about biosensors. So then understanding biochips will become very easy for all of us. Biosensors are class of sensor devices that detect or quantify a known analyte in a biological sample. So that's a biosensor. For example, is a glucose biosensor. The sample is my blood. In that, the glucose is monitored, so that becomes a biosensor. And usually, these biosensors are sensors related to any biological samples. All the body fluids you measure, or the blood, or anything that you take from your body and give it a sensor, is called as a biosensor. See, parallel to the biosensors, what are called as the chromatography techniques are available, which are very expensive and blah blah. So we use a biosensor, which are easy to use and easy to deploy, low cost devices to monitor our own health by measuring all these biological samples. So usually they are based on a biochemical interaction for their operation, like this. So we will have some kind of bioreceptor that is available here. So this is a sample that you are putting here. The sample will go and sit on this and make some changes there. So we will use some transduction technique to measure what it is. I'll come to the details in a while, and you're able to measure this. And what all you can measure? You can measure the inorganic compound like salts, or you can measure even small molecules like a vitamin or a sugar molecule, or you can even measure larger biological macromolecules like the proteins, nucleic acids, or you can even detect pathogens using virus and bacteria. See, when we were tested for COVID, obviously they used one or the other kind of a biosensor where our sample was taken from the throat, and they were able to detect whether the coronavirus is present or not on a particular technology, what is called as antigen antibody bonding. I don't have time to go to all the details, but please trust me. We'll have a bioreceptor here on which your analyte will go and sit. Now again, the specificity which will come into picture. So you are trying to measure is a bacteria present or not, or is a virus present or not, or maybe you are detecting a particular DNA, or is a particular protein present, and things like that. So we use biosensors to measure and monitor all things related to our biological samples. So this is how typically it is. So we have an analyte whose chemical compounds or constituents are to be identified or measured. So I'll have a bioreceptor. and once they interact with each other, there will be an electrochemical reaction happening here that goes to a transduction technique, wherein I can get an electrical signal or an optical signal or a mechanical signal, thermal signal, acoustic signal, anything. Any sensor principle is still valid here, but in the form of a miniaturized component. Then I do some signal processing using an embedded device, and I have the biosensor. For example, this glucose monitor what we have at our home is a standard example of a biosensor. And biosensors were initially developed to give better attention to the healthcare areas, and they were able to measure the blood gases, the ions, and the metabolites. And obviously, they allow a better estimation of the metabolic state of a particular patient. So that's what typically a biosensor does. If I take the example of a simple blood glucose sensor, I often take this example because invariably all of us have seen this working of this biosensor at our home or at our neighbor or with elderly people. So glucose is the analyte. There will be glucose oxidase that is present in this particular strip. So glucose oxidase is always there here, which is made by the manufacturer in the form of a printed on a particular strip. So now that is the bioreceptor. And once the glucose goes and sits here, there will be a release of oxygen and consumption of oxygen and things like that. But in the third generation of glucose sensors, they will release an electron for every one glucose. So then the electrons will count the number of electrons based on the current with some A to D conversion, and that's what the signal processing all about, and you're able to measure. So therefore, as I told you, all the biosensors are based on some kind of a biochemical reaction. So there is glucose oxidase present here, and the blood sample will interact with them. So glucose oxidase is an enzyme present on the test strip, and that reaction is made use by the particular thing to do that. And then you can monitor the progress of the reaction either optically as a change in the color of the strip. We have a lot of strips like the pregnancy test strip or the urine sample strip, strips that will go color changes based on that. That's one way of doing it. Or it could be electrically, wherein you measure an electrical current coming out of the particular bioreceptor to know what the analyte you're trying to measure is. This picture is very generic that will tell the typical elements of a biosensor. So you may be trying to detect the sodium, glucose, pH, lactase, etc., etc. So we have a bioreceptor, which will be in the form of an enzyme, antibody, microorganism, or a DNA chain, which are called as molecularly recognizing materials. So this will be linked onto a stable substrate, and then your analyte will go and sit on them, make some biochemical reaction, and that will result into some kind of a change. It could be an electroactive substance that is being produced, or the pH may change, or it may generate some heat, or the mass may change, it may produce some light, and so on and so forth. And then I can use one of the popular transduction principle, like an electrode system, or I can use a pH electrode, or I can use a thermistor, or a piezoelectric device, or a photon counter to know the number of photons, or I can even use a surface plasma and resonance principle and things like that. So all the sensing principle that I'm familiar with can be still applied here, and you'll get a measurable signal that goes to an amplifier, electronics interface, etc., etc. I mean, that goes on. But please appreciate, in the whole chain of things, the most important element is the bioreceptor, because that's where the electrochemical reaction is going to happen. That's where your analyte will interact with the enzyme or the antibody or whatever. So therefore, if this is not stable, nothing else can be stable. You can have the best of the amplifiers, you can have the best of the embedded board, but if this interaction is not well monitored or taken care of, the whole thing will fail. So therefore, the most important part of developing a biosensor is what is called as immobilization of the bioreceptor. It's very, very, when I say immobilization, look at this. What you say, the square box is the analyte, and what you see as a heart symbol here is your bioreceptor. This bioreceptor himself should not be movable, or he should be stably sitting on that. So that very process is what is called as immobilizing. It is not able to move. It should sit on a particular substrate, right? So that is what is immobilization. And there are various techniques like adsorption, covalent bonding, cross-linking, and then entrapment, and micro encapsulation. These are some of the different techniques. As you can see here, all of them will lead to the same situation, in which you have the matrix here and you have the biomolecule here. So within the matrix, the biomolecule is embedded. It is made to be immobilized so that my analyte will go and interact and lead to a very, very valid biochemical signal. And these are some of the signals that people have been able to measure, like water, glucose, cholesterol, or antibodies or hormones, DNA for forensics. and then upper respiratory virus like flu A, flu B, then rhinovirus, then the HIV virus in the blood sample, or the tuberculosis bacteria, or even any bacteria in the blood, or any food poisoning bacteria like the salmonella or the listeria or E. coli, etc., etc. People have successfully measured these biosensors, right? Yeah. So I suddenly took you from wearable sensing technology to biosensor. The reason is this: when I talk about a lab on a chip, as you can see here, I call it as a a bio chip because I do it for a thing, but it's a lab on a chip. What we'll have? A biochip is a set of diminished or micro nanofabricated microarrays that are placed on a strong substrate. I meant immobilization that allows many experiments to be executed at the same time to obtain a high throughput in less time. So probably it will be, hundreds of bioreactors that are present here. You will put your sample here. You can see micro channels here. So different species will find their route to different reactors. So there will be different signals coming. I mean to say, it's like, I'm sure all of us remember the chemistry lab in which we had a test tube and did some experiment to measure something. It is something like having 100 test tubes at one place. You do 100 experiments and you get 100 signals and you're making 100 measurements. So that means you're increasing the throughput. You can make a lot of measurement in less time is what I'm trying to tell you. And this device will contain millions of sensor elements as biosensors, but these are not electronic devices. Because when I say chip, what comes to my mind is the integrated IC chip. Integrated IC chip in which I can do all this. So it is not an electronic device, but it's a device like an electrochemical unit using which I measure biological parameters. And each and every biochip can be considered as a microreactor, the test tube I was mentioning, that can detect a particular analyte like an enzyme, protein, DNA, or a biological molecule or an antibody. So usually DNA is very, very highly monitored. We even called it as a human genome project, in which hundreds of biological reactions in a few seconds, like decoding genes, in which you detect a sequence of particular DNA for various forensic purposes and various other applications. In addition to sorry in addition to detecting genes, they're also used for toxicological or protein detection or even for biochemical research. So just take a look at this picture. It looks like an IC, what all of us are familiar with. Yeah, sorry. This is your biochip module with all the IO connections. So there will be a fluidic cap here, in which we'll have pixels or arrays of these micro, hundreds of the test tubes or the micro reactors, and you put some sample here. It will have inlet, outlet, etc. And you can have these probes or linkers. Linkers are those bioreceptors which are strongly linked here, and they will do some surface modification. And the rest of is your electronics. We call it as a biosensor pixel now. Uh, sorry, like what you have in an I mean, the digital camera sensor, we will have a biosensor pixel also, each pixel doing some particular measurement and making the thing. So it's possible that pixels include biorecognition elements, the probes, what I was just mentioning here, the bioreceptor, like the glucose oxidase in the case of a glucose sensor. Then you can have transducer and CMOS integrated circuits. So it's very much possible to integrate your CMOS integrated circuits along with the CMOS compatible transducer. So people have successfully demonstrated quite a number of biochips to make various measurement. And probes can define different molecular specifications at individual pixels. I mean to say different probes will be able to detect different molecules. Like as you can see here, they have detected different DNA strands. And all relevant detection modalities are CMOS compatible. I just mentioned that the output signal could be different, like it could be fluorescence, bioluminescence, impedance spectroscopy, or even charge based. So for DNA sequencing, for microarrays or immunoarrays or DNA sequencing, and so on, people have developed a lot of these particular sensors. So it is very much compatible with CMOS. So biochips is that combination of the CMOS fabrication along with my biosensing pixel, and are able to do that. So to conclude, I spoke about the healthcare in general. Then I took about the 5 application areas requiring remote monitoring. Then the 4 body fluids that gave me, non-invasive type of wearable sensors. Then I took some 4 or 5 interesting examples. Then I connected the wearable sensors to make a wireless band and a medical IoT, and I gave an example of an end-to-end IoT system. I spoke about the applications, key impact areas, and also the security things. Then towards the end of it, to justify the title I had suggested, I spoke to you about biosensors, which will lead to the so-called biochips, right? So with this, I'm at the end of the talk. If there are no questions, it's okay. If there are questions, probably I'll take one or two in the interest of time. And sorry if I exceeded your time by 5 minutes or so, right? So with this, thanks again for the opportunity. It was nice addressing all of you, though it was online. Hope you enjoyed the session, and let me know if any question is there.
Hello, sir.
Yes, sir.
Sir, you told which is the strong substrate. Which one strong substrate indicates what it is?
See, when I say strong substrate, these
Which
biomolecules which are
element?
working as bioreceptors are basically immobile in nature.
Hi,
Right.
sir.
Like, for example, I showed some kind of sensors that are worn on the body of the thing. So you should have a solid substrate on which we immobilize them. That's what I was trying to tell you.
Okay. Sir, that substrate is electronic or something you are telling?
No, no, the electronic one.
Like,
I can use, I mean, silicon based or anything I can still use. Yeah, yeah.
mm. And then see, sir, can you recall this mole, sir? Mg2 plus and HCO3 minus you given, sir. What is this 2 plus?
Can you repeat your question?
Sir, while you are telling these molecules,
Hmm.
in that there is a level you given, sir.
Ah.
Glucose sensor. In that Mg2 plus is there, HCO3 minus is there. Plus means what, sir? Minus
A
is what?
plus minus will indicate whether it's a cation or an anion. Is it positively charged or negative ion? We detect those ions using them.
Okay, okay, sir.
Yeah.
Then, sir, in last slide, before last slide, you kept that ETC.
Yeah.
Capital ETC. What it is, sir?
ETC, yeah?
Yes, sir.
1 second, let me check. Here or previous?
Previous, sir, previous. And previous. Go.
Go back.
Back, sir, back.
This?
No, 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 sir.
I'll go back. You remember the slide
Yes, sir.
number?
Slide number, it is at biochips. At biochips, it is there, sir.
Here?
Before. At starting of biochips, I think second slide, sir.
Here?
See, sir, at last. You given some vitamins, proteins, pathogen, and then ETC you given. That is extra or something? ETC means there is something.
Can you read out which line it is?
Sir, in biochips, I think it's at last you given salt in and then vitamin, small molecule proteins and nucleosides, pathogen, virus and bacteria, and then ETC.
Okay. Anyway, I'm able to go to that. It could be some kind of an analyte that I'll detect. Probably can Google it and find it. In the interest of time, because I have another session at 11:30.
Also,
Yeah.
okay, sir.
Yeah. Always remember the
Sir,
slide
you see,
number so that it will be easy to discuss. Yeah.
sir, actually, one suggestion, sir. Actually, we met one interventional cardiologist. Actually, what they are asking, can you do any nanorobotics without making these wires to while you are taking these stands?
Hmm.
Can we send the nanorobot? Can we operate through wireless?
Yeah, I mean, see, technology has no, ends to that. Nano robots have been fabricated in way they're inducted and they go to the site where the treatment is required and they inject what is required for that. And they're wirelessly monitored also. They are made.
Please stop it.
Already.
Yes. So ML model, what are the two metrics that they use? Anybody?
Hello, I can't hear you. Is there a question there?
Yes, sir. If it is nanorobotics, what nanometer technology present work is going on, sir? nanorobots.
Yeah, nano is not my domain. Probably I need to look into that and tell you what's happening with the nano. But lot of things are happening with the nano. In fact, all these are possible because of the biochips are have come up because of the technological development that has happened in the domain of nanotechnology. Everything becomes nano at the end of the day. In fact, I give a separate talk on the impact of nanomaterials on biosensors. So probably it's covered in a different topic. But see, if you look at the three generations of biosensors, the initial thing was based on the hydrogen peroxide that was released based on the reaction. But if you look at the 2G thing, they used a mediator to take out the electron that is generated. But today we talk about DTE, which is called as direct electron transfer. Here what they do is they will have this nano rods made of gold and silver, which can go to the center of that glucose oxidase, which will have very complex structure and take out that electron, thanks to the nanotechnology.
Yes, thanks. Sir, actually, whatever simulation you are doing up to now, simulation is going on, but finally, when we are manufacturing, at the nanomaterial science, we are stucking, sir. What materials we have to use, which material support finally for coming to the fabrication? There, if you
I
possible,
mean,
this can be
see,
arranged, sir.
all the fabrications that are valid will also they say, but we have to check out some compatibility because some of these things could be toxic, which are not well go with the established IC fabrication techniques. So based on that, we have to take a call.
Okay, sir.
Yeah.
Okay. Thank you, sir. Thank you.
Yeah.
Thank you, sir, for addressing all the questions.
Yes, madam. Thank you.
Thank you, sir. It was very insightful talk on healthcare applications. The session
Yeah,
was very
thank you.
informative.
Thank you,
I
madam.
thank
Thank
all
you.
the participants for joining. So let us break for tea for 10 minutes, and the next session starts at 11:30. Thank you all.
Yes, madam.
Ma'am, am I audible? Antara, ma'am?
Yes, it's audible. Hello?
Yeah. Welcome back, all the participants. Yes, ma'am. Welcome back, all the participants. We have the next session by Professor Antara Roy Chowdhury, BMSCE, Bangalore. Welcome you, ma'am.
Good morning to all, one and all the participants. So last 2 days we were discussing the machine learning and the artificial neural network when it is getting applied to the medical data. So, and as per the schedule, as ma'am suggested, students' agenda was to do the PyTorch analysis with the medical image data. But there is a slight change. That topic I'll be doing it tomorrow, because tomorrow, I mean, for that we need to do some installation. I think that installation I have not told you yesterday, so many people would not have done the installation, so it will simply waste time. So what I decided, like tomorrow's agenda was doing the COVID data analysis. That I'll do today, and tomorrow no audio. Is my voice coming? Someone is
Yes, ma'am. It's audible, ma'am.
Yeah. So I'll ask your permission to change the schedule. Tomorrow's whatever I was supposed to do, COVID data analysis, that I'll be carrying out today. And tomorrow I'll be doing the medical analysis. Is it fine?
Yes, ma'am. Okay, ma'am.
Yeah. Okay. So I'll share my screen. 1 second. So I'll be requiring some installations to be done. That is why I'm not doing it today. Yeah, I think my screen is visible to all of you. And okay, let me go here. One second. Just give me 1 minute. I'll share the link as we do every day. I'll be sharing some link with you, and followed by we will be carrying out. I think all of you have the link of BIT FTP that wherever we are using. Anyway, I'll share it with you. So I'll share the link. Again, I'll chat in the chat section, posting the link. Yeah, please check out the link, go there, and it will open inside that folder. You please go to the folder called day 3. And inside day 3, you will be getting 2 files. One is the CSV data file, another is the to share, right? I mentioned it as to share COVID-19 data. That should be fine. Yeah. Please open this file to share. Okay, and now let's open this file. So once you open the file, you should be able to see a file like this. Now let's see that first what we want to do and why we want to do this analysis. So as of now, whatever discussion I have done, so that was regarding the disease prediction, correct? Once we have some data set, I should be able to see whether this disease is there or not. Say, let it be a diabetic disease or a cardiac disease or whatever it is, correct? So now what we want to do, we want to do some modeling with the COVID-19, so which has been a recent pandemic and which is fresh in all our mind. And with this, I'll be showing you, it's a quite popular topic now, the forecasting or the time series analysis. So any kind of time you have any medical data which requires further forecasting or any other kind of analysis. Right now, it is very relevant now because we'll be always like seeing the graphs and predicting the trend, whether we are going to have any more wave or not. That is my forecasting part. Or else we'll be doing some analysis to check out which particular zone of the country is now mostly COVID affected and where the death rate is more, where the recovery rate is more. So all this analysts will be doing and followed by the prediction. Okay, so this is where we are going to do the medical data analysis, but now I am not doing that with the detection of a disease. Okay, we are slightly changing and seeing that with the medical data, how we can predict the future outbreak will be there or not, and all this kind of data analysis. Okay, and it's very relevant nowadays because just after the recent outbreak of COVID. Okay, now so I'll be start doing. I think all of you have opened this one. And as I've suggested, please don't change that code. Please copy it in your Google Drive folder and start doing. Okay. So first, let me explain what we are supposed to do. And then I'll just ask you, just give me some time. I'll just explain the code. Okay. So, okay. First, what you can do, you can download this data set. Okay. This COVID-19 clean complete, this CSV file you can download. And as we are doing in the last 2 days, that okay, you go here. Just one second. You go to this file portion and upload it. Okay, you can upload the CSV. Fine, and you can read the file with a command called data frame. The pandas dot read CSV. That is also absolutely fine. Or else if you have the data directly at a particular link, so it is there in a GitHub of particular user, so you can use that link directly also to be mentioned here. So right now, let me go and show you what is the data I have in this particular link. So once I open this, so see, this is a CSV file we have. I'll just zoom it a little bit. So it is a comma separated file with a province, state, regional, latitude, longitude, date, confirmed cases, death, recovery rate, recovered number of patient, active number of patient, and so many things are there, correct? Okay, so what we are going to do here, we're going to use this data for our analysis. Okay, all of you can click on this link and you can check it out if you are getting this details or not. Okay, so just one second. Okay, now so what we have done, first we have written as path, and in the path I have written the URL path. Okay, followed by, as we have done yesterday, we were supposed to load some library function for us. So NumPy, Pandas, Seaborn. Yesterday also we have seen this Seaborn library. It was useful for our statistical plotting, correct? Statistical analysis. Followed by yesterday also we have used this matplotlib and the plot TUI. All these things were used yesterday, correct? So let me just execute it. Okay, now because it is there in a path, and in that path, in this path, correct? Okay, by the way, is the font visible or should I zoom it? Is the font visible or should I zoom it? Is it fine for everyone? Is it visible? Is my voice clear or it is blurred? Is it visible?
Yes,
Okay.
ma'am, it's clear, ma'am.
Okay, fine. So what we are supposed to do, we are supposed to read the CSV file. So that pd.read CSV followed by path, and what this head function will do, head function will print my first 5 lines and see that what is the data all about. Okay, now see how my data looks. So this is the data I have. This is anyway the ID, no issues. This is where this is province or state, and this is the second one is my country or region. So remember, a particular country can be there in a multiple times in this data, because for a particular country the different state data will be there. Okay, so country column is not unique. Country column will come multiple times. I mean India will be there multiple times for all the states it has. Okay, followed by we have the field as latitude, longitude, lat long, followed by we have the date. Okay, in this particular date, so by the way, this is the data initial COVID-19 when it broke. That time from initial, it was I mean when 2020 when it broke out. So that time initial data we have, so that we can see nicely that how the curve is, because that is the time when we had a havoc change in the per day peak has reached, and then it came down and all those. Correct. The first wave time of data when we started with facing the COVID-19. So date and followed by the number of confirmed cases, death, recovery, and the who region, in which region it is in. It's in the region of Europe, Africa, or whatever it is. Okay. Now what we are going to do. So if you see the data, hopefully you should be able to understand there are some columns I am not interested in. So can you see there is a column which is there as a province or state, and mostly the values are not there. It is called NAN. I mean, we can say it's a missing value. Yesterday we were discussing, right? If you have a situation in which you have a lot of missing values, it is not applicable, not available values. So what we are supposed to do, we are supposed to remove this column. Correct? Drop this particular column, province or state. There are other columns also which we are not interested at all. Someone has unmuted. I'd request participants to please mute yourself. Participants, please mute yourself. I would request the participant to please mute yourself.
ಆಮೇಲೆ ಸರಿ ಎಲ್ಲ ಆಮೇಲೆ ಬಿಸಿ ಇರ್ಬೇಕು ನನ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಡಿಸ್ಕಷನ್ ಆಗಿದೆಯೋ ಏನೋ ಗೊತ್ತಿಲ್ಲ.
From host side, can you mute all the participants? Okay, I think it's all fine now. Okay.
Yes, ma'am, you can start, ma'am.
Yeah. So, okay. So what we are supposed to do, yeah, I was discussing that what to be done with this data. Once I have this data, you have to first understand what is that you are interested in. I want to know that what is the COVID situation in my country, what is the current situation, how many recovery rate and all, and followed by I want to do the future forecasting, correct? That is what we have to do for any kind of disease outbreak. What is the current situation and what can be the future? So for that, we don't need this latitude, longitude information at all. Correct? We don't need this location information. So once we have this data, we can drop this columns, province or state, followed by we can drop the column latitude and longitude. Okay. Followed by we can rename this column, which is the second column, which has two names, country and region. For removing the ambiguity, let me rename it as only the country. Okay, so what is that I want to do? Initial data pre-processing. We are in the data pre-processing state right now. Initially, we are doing the removing the extra columns and all, and followed by we'll be doing that EDA, that is my exploratory data analysis. Yesterday we have seen, correct, how we can visualize the data and come out with some meaningful informations. So we have to remove the unnecessary columns, that is the first column and the latitude, longitude, and without removing the ambiguity, I'm going to rename the column country or region to as only country. Okay, let's see, let's come down and check it out how it is happening. So first we are supposed to drop the column province or state, correct? So DF, what is a DF, by the way? DF is somewhere where I have loaded. Yes, DF equal to pandas pd.read.csv. Okay, so DF is my data frame on which I am working with. Okay, DF is a data frame. Now on this data frame, first I'm going to remove, drop the column, that is my province or state, and access equal to 1 because I'm going to remove the column, correct? And in place equal to true means that DF, the original data set, should be changed. And let me print the first 5 rows and let me check out whether the province or state column is actually dropped or not. Once you execute it, yes, you can see the province or state column is not there. Now what change I have to do? I have to remove this latitude, longitude column, and I have to change rename this particular column country or region. Okay, so let me carry out the operations. First, I have to rename the first column now, that my country or region should be renamed as only country. So let me execute it. Let me check out whether I get the proper output or not. Yes, now you can see the first column, which has only the country or region, it is only named as country, correct? Now, so up to this column we are done with. So next what I have to do, I have to remove the column latitude and longitude. That is my unnecessary information. So now let me remove it. Oh, 1 second, I think by mistake I have deleted that particular column. Okay, doesn't matter, let me remove it here. So what you can do, let me just copy paste this column. So let me go down in here. You can add a code cell here. Okay, so instead of this province or state, now I want to remove 2 columns and the name of the columns is lat and long. So I want to remove the column latitude, followed by I want to remove the column longitude. So remove the column longitude. So unnecessary information, I'm done. And then print the def.head. Yeah. So now you can see that all my unnecessary data is not there. I have only my necessary information, that is the country date, and followed by the status of my country or all the countries in the world right now. And on this date, I have to do some analysis and predict the future. Okay. So I think these things that we have done already. Yeah. So df.head. So right now this is my data. So I have got country, date, confirmed and all. Okay. Now. Okay. So I'll request all the participants please to do up to this step, and then we are supposed to start with active data calculation. I'll do one thing. Yeah, you can start doing, fine. You can start doing. Everyone, I'll request everyone to start doing. And continue it up to just before you calculate the active. Please share. Which one is not shared? No, I have shared it as to share folder. If you go here, second, if you go here in this day 3, it will come as to share COVID-19. It is not shared. I'll just do one thing. I'll check it out if it is not shared. Okay, let me do it as I did then. Check it out now if you can open that particular file. Kindly let me know that whether you can access the file and do it up to the removal of unnecessary columns. And then we are supposed to check how many active cases are there, and we are going to do some plotting and predict the future with Facebook profit model. That is a new model that I'll be introducing you today. That is a time series prediction, time series analysis for any kind of problem in which you have to do the time series prediction, time series analysis. That time we use a model if we profit. That's my Facebook that has been launched by Facebook, the profit model. Okay, so we will see it. But I want to know that if the environment is ready for everyone. Okay, so someone is requesting me to share it again. So I'll post one second, sorry. I'll post the link again, 1 minute. So I am sharing the link, the collab link directly I've shared. Let's check it out whether you can open the collab link. But please don't change there, okay? I request, please don't change there. Copy it in your local drive and then change it. So please check it and let me know after you finish your initial state of data preprocessing. Yeah, sure. You all of you. So only one participant is responding. What about the others? All of you are done, not done? I request everyone to be please responsive so that we can discuss. And if you want, yeah, not done it. No problem. Please finish it off. Once it is done, you let me know. No worry. I'll wait for everyone. Do up to the step when you have removed the unnecessary columns, state column, latitude, longitude, and renamed the column as to country. By the way, this step I think was not there in the code that I've shared. Kindly you do it on your, I think you should be able to remove the 2 unnecessary column lateral. The code I have done right now, I'm just highlighting that code here. This code was not there in the file. Drive link. Which drive link? I've shared already, no? I'm not sure which link you need. You need the collab link.
Yes, madam. Actually, now at present it is opening. Code is opening, and that you have code.
Yes, sir. Yes, yes. That one Cola file is fine. You don't need the dataset. Dataset is just given for your reference, but the dataset is already available in the GitHub. Okay, so I'm loading the dataset directly from the GitHub.
Okay.
So you don't need the dataset as such separately.
Okay, madam.
Okay. Thanks, sir, for asking.
Okay, madam.
Okay. Kindly finish it off up before this. After you do all the processing, your data should look clean like this.
Madam, first step is okay. Second step, DF is equal to cv.read is coming wrong. Name error.
First step, you redo the first step in that case. This is the path you initialize again, followed by you import the necessary library, and then do the read CSV. It should be working. I think your path was not there properly. Please restart. Now it is coming?
No, madam. Path I have to set. Any path I have to set here?
It is there already in the to share file. Vanishri is saying
Path you define, madam. Yes.
no audio. So 1 second. Vanishri madam.
Actually, input is first.
So Vanishri madam is saying no audio. So guys, is my audio coming or I'm muted?
No, madam. Have it
It's
coming
audible,
out.
ma'am.
Okay, so Vanishri madam, please check your audio connection from your side.
It's okay, madam. I can start now.
Okay, so Ritvika has told that it is not work as of now, not done. So is it done for Ritvika? Can I start? I have renamed the columns. Yeah, you have renamed the columns, and you have. I think you would have dropped the unnecessary columns as well, right? I mean the lat long and all. Yeah, done. Thank you. Okay, so now let's start with actual analysis. Okay, so this is all done. Now what do you want? I want to add a column. I want to change the column active actually. So there is a column active and where you see mostly the values are 0, 0, 0, 0. So what do you want? I want to create a proper active column. What is an active number of cases? Active number of cases for any country, any situation of COVID, we know that is a total number of confirmed cases as of now, minus how many people have recovered, minus how many people are dead. That is the number of active cases, correct? So if you execute this code, it will calculate for each and every data line in that way. Okay, by the way, let me see that what is the size of the data. I have not shown that one. No? Once let me do add code. You just see that. Maybe let me do it up here. Just check it out. What is the size of the data? I mean, how many number of rows you have, how many number of column you have. For that, you have the df.shape. I think last 2 days we're using this command. Okay, so right now you see that it's a huge data set of around 38,000 rows are there all totally, and each one of them have 10 columns, correct? So this is the size of the data we are working with, 38,000 data rows. Okay, now what I want for every data row, I want to calculate something called active, which will be my active number of cases. So let me execute this one. So it is showing me the green symbol, means it has been executed. Okay, so now I want to add that value, whatever is active cases, in my data frame. Okay, so I'm adding this active values, and let me add it. Yes, and let me print it. So either you can print it with head or tail. If you print it with head, then it will give you the first 5 rows. If you print it with tail, it will give you the last five rows. Whatever it is, it doesn't matter. By the way, I think I have done something wrong. Just give me 1 minute. Again, for me, lat long and all these things are coming. I think I restarted the data loading again. Just give me 1 second. By the time you can also keep doing. I just do all the steps before. I think just to show you people, I just restarted the execution, and so my data removal got deleted. I have to do it again. Just give me 1 second. So here we are dropping this lat long, and then we are renaming the column, checking what is there in my data, and then I have checked the shape of the data, and right now I'm calculating the active number of cases, and here I am adding a column active with the details. So if you see here, yes, so now I don't have this unnecessary columns. So it is showing me the data with whatever country names we have, followed by the date, and in that date, if you see here, how many active number of cases we have. Okay, I hope all of you can see this one. So it is showing me the data for all those countries in which you have the active number of cases. Okay, and right now I have printed it with tail. You can print it with head as well, so that you can get the first 5 rows. Doesn't matter, whichever it is. So I have the values in this active column right now. Okay, now what I want to do, this info, if you want to print, okay, not talk on this. Okay, so let me print info, which will give me the idea of how many columns I have and what are the data types of each and every column. It is very necessary to do, because yesterday I have told you mostly we would like to work with the numerical columns, correct? If we have some column with a string value, we will categorical value, we have to change it, or like this, you have to do some data processing with the non-numeric values, or not in this, with the columns which are not in the standard format. So for that, you have to first use this info command and check what are the columns I have and what are the data types? Can I directly use it for machine to feed it in the machine learning model? Yes or no? So let me execute this command. Okay, so now if I execute it, you will see that what are columns I have. So right now I have 7 columns. Why 7 columns? Initially it was 10 columns. Now it is 7 columns because 3 columns, latitude, longitude, and that state column I have removed. Okay, so right now I am left out with only 7 columns we have. And if you look at the data, so this country is an object. Okay, country is anyway, it's a string, so it's okay, it's an object. And this date is also an object. Can you see that? Other things are fine. Other things are integer. This who region is also fine. This region and this country being an object is fine for us. Okay, because it will be either Europe, America, India, something like that. It's fine. But with this date, which is taken as a string, is a problem for me because I have to do some analysis with the date. Correct. So I want to say that, okay, say 22nd of March, this many number of cases are there, and 23rd of March, this many number of cases are there. So I have to forecast with the past 2 days what will be the number of cases in the next day, that is my 24th of March. So this date, this particular field, which is showing as my object, I can't keep it just like that. I have to change it to a date time field, okay, so that I can extract the dates properly and I can do some analysis with that. Okay, so this, I hope it is clear. So this field data type has to be changed. It can't be an object. So for that, what we are doing here, so the very simple thing you have to do, you go to that particular date column. So how to go to that particular column? We know it's a data frame, and to go to this column, I have to keep it inside the inside the index. So right now I'm going to the date column, and date column, I'm changing the data type to date time. Okay, so right now this pd dot to date time will change the data type of the column from a string to a date time data type. Okay, which is easily processable, from which we can extract the data and we can process it in the ML model. Okay, so right now I'm changing the data type. So it is executed, and now again give the info and see that whether it is what is showing as a data type of the date column. So I'm executing it again. Now if you go down, for this date column, I'm highlighting the row. For this date column, it is the data type is showing as date time. Okay, so now it is fine for us. Okay, now just quickly have a look at what is the data I have, initial data. So I have the data as country, date, and all this stuff. Correct. Now, what is the processing I have to do now? I want to do some kind of plotting. Okay, I want to know that currently which are the countries which is facing the maximum COVID cases. I'm repeating what I want. I want to know in the currently means as of now, whatever data I have, okay, whatever data I have with that taken as a current, what is the maximum, which are the countries which is having the top COVID cases. Okay, so how to do it? Then which date you have to check? You have to check the date which is the maximum date in that. So if you see this file, let me go to, when I open this file, let me go and show you this file. Just, you can also just try follow this link and you check it out how this data is there. So the data is there as say 22nd January 2020, and it goes on and all. And it's a huge data. It's a 38,000 lines. I can't scroll it like this. So it's a huge data. And so as of now, you're having all the data of the 22nd January of all the countries in the world, correct? Followed by you can have the data of say 22nd January. And I think the last data it is there. It is of 24th something. Okay. So let me check it out that which is the last date I have. So let me go here and check it out. It started with 22nd January, and which is the last data I have. So for that, what I have to do, you have to check out which is the maximum date you have. That's what we are doing. Okay. The last date means which is the maximum date you have. That is the last date, correct? df dot date equal to max. It will give you the last date. And what you are doing, you're extracting all the data of that date. I'm repeating what we are doing, what this top will contain. This top will contain all the data belonging to the last date in the file. Last date means the maximum date in the file. This top will contain all the filtered data of all the countries for the maximum date, the last date which is mentioned in the file. Basically, you are doing a filtering. This is not equal to, this is equal to. So whenever in a particular line, the date field is matching with the maximum date or the last date, you are filtering out that column and taking it in the top. Okay, let me see and print this top. You can print it entirely, it's a huge one. So print it with the head command and check it out which is the last date or the maximum date you have, and what are the data I have. Okay, so let me execute this one. Okay, so it is telling me the last date you have is my 18th June 2020. Okay, I think you can see here the last date that we have in this file, that is my 18th June 2020, and it is showing you for all the countries what is active cases, what is the number of deaths, what is the number of recovery, which is the number of total confirmed cases as of now, and all those data is being shown. Okay, so I know that as of now, we're up to 18th January, this is the status. Now with this data, what you can do, by the way, I hope one thing you remember, this country, I told it in the beginning only, this country column is not unique. I hope you remember that, and I told you also why it is not unique, because you had one column before that I have deleted, that is my state or province, correct? So for, if I say my country is India, so India will come multiple times with all the province, say Jaipur, Rajasthan, Karnataka, and all those stuff, correct? So what I want to do now I have the, okay, this is the situation, current situation of the last date. Now I want to know per country what is the situation. Okay, because I told one country can come multiple times depending on how many state data has been recorded. So then what you have to do if you want to know the country wise, because that's what was showing in the news, right? This country is suffering the most, this country is suffering less. There's a total of a per country statistics. So what you have to do, you have to use the group by command. Okay, from the top is the data frame, correct? So top is this data frame, wherever I have filtered out the data belonging to my final data. So in that, what you are doing the country command. Your you're doing a group by using country, because per country you want to know how many number of, what is that I want to know? I want to know how many number of confirmed cases, how many number of active, how many number of recovery, and how many number of death. How should I group by? You should group by country and you should use the function sum. Okay, so per country, how many ever state is there, for everything it will give you a group wise sum, per country summation you will get of all the confirmed cases. Okay, followed by there's one more parameter that is called reset index, so it will again start with a 0 1 kind of. Okay, so let me execute this one and let me see that if I print, so this is a world data, because so right now, as of now, whatever you have, you may have one country repeated multiple times. Now when you go here, you will not have one country repeated multiple times. So one country will come only one time, and you will have a consolidated data of that particular country. Let me execute it and see what is there coming. Yeah, so if you see here, so in the data set, you are seeing that in Afghanistan, there's a situation, and in all the states, all the other countries. So you're using it here only head 5, and this data is sorted according to the alphabetical order of country. Okay, so that is why it is coming in this manner. You can give the tail command to see the other portion, or else you can filter it to check it out what is the situation of India also. Okay, so as of now, what I have done, okay, let me just show you the next command also, and let me show this one. Okay, so as of now, what I have got a worldwide situation, that where my COVID has affected, and what is the situation, what is the number of death, what is the number of recovery, and what is the number of confirmed cases and all. Now, how do the viewers would like to see it? Everyone would like to see it in a map format. That's what is the format we are all getting, correct?
468
So,
basis score. Okay,
just
so
one
the
second.
scores are just given. These degradation errors are just given for the 468.
Yeah, sorry for the interruption. So now I want to plot it. So let me show you how the plotting will look like, and then I'll explain all the parameters. I want to show it as a world map. Okay, this is the output I want to have, and I'll explain all the parameters, nothing to worry. So I want to plot a world map. Okay, so if any situation is there when you want to have a world map kind of a plotted or a country-wise map plotted, so that you can easily visualize the data. Now nowadays, any kind of data analysis application you want to do, it is very much necessary to look at the visualization component also, because the visualization gives us a lot more insight than looking at the numbers as such. So what it is done, so this is a world map, and how it is recorded with the number of deaths. Okay, so and it has been colored with the different variation of peach color. Okay, so light peach color means that number of deaths is less, and the dark peach color means the number of deaths is more. Okay, and here all the countries in the world is mapped, and the color coding has been done depending on how many number of death has happened. And if you check it here, how do I know that which is a country? So if you hover your mouse over any of the zone, it will show you which is the country. For example, right now I'm hovering here, it is showing me this my country is Australia, and the number of deaths is 102. So you're hovering, I have enabled the mouse hovering equal to true, and I've seen that when I hover my mouse, it should show the country name followed by the number of death in that particular country. Okay, so if you see here the situation of India and all those stuff are here, all the required stuffs are plotted here. Now how to get to this plot, just let me explain all the parameters. So what we are doing, so we have started with this plotting, followed by what I want to plot. I want to plot the world map. Okay, how I want to show it, I want to show the locations according to the country. Okay, how many ever country is there, you show the locations. Okay, and this location mode equal to country name. I mean, that is why when I hover my mouse over any portion, the location name is showing at the top. If you see here, it is showing as down, it is showing as country called Australia, but up also it is showing as country name, that is my Australia. So each and every location is enabled with the location mode, which is set as the name of the country. Okay, now then how to color the different zones? I told you it has been colored by the number of death that has happened. Okay, so it has been colored with the death column. Now which color I'm going to use? I have used the color peach, so that it is giving you this particular shading. Okay, if I just, let me change this one. So if I change from this peach, if I change this to blue, it will give you all shades of blue. What happened? Something wrong, I typed or what? Okay, let me just send you, it doesn't matter. Let me just change it to peach only. The blue was not taken. Okay, so it is showing me all the variation of all the shades of peach color, from light peach to the dark peach, and where I can get the meaningful information that what is the situation of the world, which are the countries which is suffering more, that Canada, US, that time it was suffering like anything. Okay, so up to this I have told you. And the range of color, yeah, so range of color means 1 to 1000. Yeah, so this is the maximum, that is 1000, and it has been started from 1. Okay, and yeah, so and the title of this map is countries with active cases. So this is what is the title of the map? That is my countries with active cases, and the hover name equal to country. I mean, when you hover on a particular area, that's what I was telling. When I hover my mouse on a particular zone, it should show me the country name. Okay, so that's what is being shown. Okay, so like this, very easily you can use your Python code and take any data set and plot the map and visualize it in 1 minute, because otherwise it's a huge data set of so many rows of so many different countries. It is very difficult to predict any meaningful information out of it. So you can visualize it very quickly and get the meaningful information that where and where it is very safe here. So I know this other countries which is very safe. Now Australia is very safe, whereas that US, Canada, they are suffering with a lot of death threats. Yeah, so I hope it is understandable as of now. I request everyone to please check it out, execute the code up to this, whether you're getting this map or not. I'll wait for everyone. Any doubts, you ask me. Please see that if you're getting this map or not, and if you understand all the parameters, how we are plotting this map. Okay, so one person has told they are getting the map. Let me wait for other 1 or 2 people. Getting map done. Okay, fine. Okay, so now let me know. So now we know that what is the current state, correct? Now how map is coming, we are plotting here, no? See here. This is where we have initialized. Okay, maybe it has gone down this side. This is where we have initialized all the parameter of the graph. Okay, then we have used this figure dot show so that this map is plotted. If I do not use this show command, let me just execute this one. Now you will not see any plotting. If you want to see this graph, you have to use this show command. Now if I execute, it will plot this graph. If you're not getting the graph plotted, maybe you have not executed the show command. Please confirm if everyone is getting the person. Is country the keyword? Country is no. For showing country is not the keyword. Here we are annotating the entire world map by the locations where the location is set as a country name. But to show the map, country is not a keyword, I should say. I mean, what do you mean by keyword, by the way?
Madam, how
Here
world, madam?
How?
World map is coming, entire map is coming.
How world map is coming? By this one.
World, yes, world is a keyword, madam. Okay, then. World
Yes.
location is equal to country.
Yeah, yeah.
Okay. Okay,
The
madam.
world map you are loading with the keyword world. Okay. World map I'm loading with the keyword world.
So, okay, madam. Okay, then.
If someone is messaging something, let me check. Blue is equal to showing. Okay. I think I have done it blue, right? I would have given. Okay. So someone has messaged me. Thanks, Ritvika. Ritvika has pointed out that I have typed the data in blue. So blues is working. So let me check it out. Yes, it is blues only. I think. Yeah. Yeah, correct. Yeah. So if you type instead of thanks, Ritvika, madam. So if it is blues instead of blue, if I write blues. So if you want to change the different shade of color, yeah, right now I have a different variation of blue color, whatever color you want. Okay. So these things, anytime if you are confused about what will be the parameter, how many parameters are there. Yesterday I have shown you can write this function followed by a question mark. Okay, yesterday we have seen, and it will open the help menu for you where you can see what are the parameters, and in that particular parameter what are the values can be given. Otherwise so many parameters, it's very difficult to remember what is what. Okay, anytime you can check it out. Okay, so thanks. So I think I can move.
India with another color, madam.
Hello.
In that color, blue color, can we highlight the with a different color like pink or red, whatever it is?
I did not get it. So you want me to use both the colors?
No, madam. Highlight India color, madam, with a different color. either pink or red or yellow.
Instead of blue, I should use some other color.
No, entire wall map is there in blue color, na madam.
Entire, see, right now we have given it as, see, you can see right now we have given it as a color as a continuous scale. Okay, there are many ways of plotting it. Right now it is shown as a color as a continuous scale, and it is varying with the different shades of blue because we have given it as color as a continuous scale. Okay, other than this, you can plot it differently also, as I think you want it like this. If the color, let me use different colors. So yellow means there is very, or green means the zone is very safe, so very less death. Red means the death is more, like that, right? Different color you want to use. In that case,
yes,
you correct. So you can do that. I'll not showing the code, but you can do that very easily. You have to remove this one. Okay, you can't use in that case a color continuous scale. You have to mention an array kind of a thing. Then you have to mention that in this, if the death is in this zone, then color it with red. If the death is in this zone, then color it with some other color. You can do that. Right now it is shown as a continuous scale, so it is coming like this. You can have a discrete zone also. No problem with that.
Okay.
Okay, you can just, this in that case, you have to just mark it out. In this range, what will be the color? In this range, what will be the color? That's it. As a discrete also you can do. Okay?
Okay.
Yeah. Okay. So right now I've told you that how you can visualize the data and easily identify your meaningful information. Now, sorry. Okay. Just let me remove one. So now, let me execute this one. And then I'll show you what I want to do. Just execute these commands. Okay, so what I want to plot first, I'll explain, and then I'll show you the code and that how we are plotting this one. I want to plot a per day kind of a graph. Okay, I want to, the x-axis will have the dates, and you can understand there is it started with the data of January, and it is the ending data I think was of 18th June. So you can't plot it as such for every point of the graph. So you will index it, you will label it, or you will show it in between some dates, but the data belonging to all the dates should be plotted. So what I want now, I want to have a plot of date wise. Date wise, I want to know what is the number of confirmed cases of wholesome of the total of all the countries. Okay, so what is the number of total global? I want to know global statistics of how much number of confirmed cases are there and how much what is the death rate, how many number of deaths had happened. Okay, seeing both these things, I should be able to get the death rate, and I should be able to know that how much deadly is the virus. Correct. So right now, if you see, this is a plot. I'll show you how to plot it. So if I plotted, what is the implication I have? So this confirmed is my red line and the death is my blue line. So if you see here, so we can see this death confirmed, though the confirmed number of cases is having a very sharp increase. Can you see which date? I'll see here. The date is around mid-March. Correct? Can you see the date is around mid-March here? It was March because the before date is March, and here it is April. So it is February, March, April, May, June, like that it is going on. So I think here it is around mid-March, the number of cases are having a steep increase. I think that time only we started with a lockdown, if I'm not wrong. Correct. So this time onwards, we are seeing a steep increase in the number of confirmed cases globally, I should say. But here, if you see here, the number of death is not showing that much steep increase. So the number of death is increasing, but it is not as steep as the outbreak of the virus. Correct. So I know that the death rate is almost though it is increased, but it has not gone beyond a certain level. Correct. It is not exponential growth in the number of cases, but it is not exponential growth in the number of deaths. Correct. So now coming to this, so this kind of graph will give you an idea about how much deadly the virus is, which is very important. Now let me see that how to get this graph. Okay, so now what I want to do a global graph, and I want to do a group by, not according to the country now, because I want to have a global statistics. I want to do a graph according to the date. Correct. So you have to do a group by command. with date. Okay, so what I am doing now, so total I have to get a total confirmed cases. How to do that? That is my data frame dot group by. Now group by on what field I'm doing the group by? On the date. Okay, so on a particular date, how many ever countries are there, or whichever data is there, please give me the summation of all the data. So that's what we are doing, the group by date. And so which is the field we're looking at? Date and confirmed, and we are getting the summation here. Okay, so you are from DF, you are looking at this two field, that is my date and confirmed, and you are getting a summation. Okay, so this is what will give you the global statistics of a per day, how many ever confirmed cases are there. Okay, so this will give you the global confirmed cases per day. The second line where you are summing it over the death, it will give you the global death on that particular day. Okay, and let me plot it, the tail. Okay, let me plot the last lines. So what is that I'm going to get? Tail will give you the last 5 lines. You can use head to take the first 5 lines, so it doesn't matter, whichever you want. Okay, so let me go down what is showing me. So it is showing me as last day I have used, I mean it is showing me the last dates. So my last date was my 18 June. So it is showing me in the up to the 18 June. So this is what is my content confirmed. Okay, so similarly you can print the here we have print the confirmed cases dot tail. So let me print the death cases. Okay, copy paste. Let me print the total number of death cases. So okay, so I'm printing the total number of deaths here. So okay, so once again, I think one is getting overridden. Just give me 1 minute. Let me add a code cell here. So let me execute it again. So right now I see this is the number of confirmed cases I have. And now let me print what is the number of deaths I have. So it is showing me on 18th June 2020, I had this huge number of confirmed cases, but the number of deaths, global number of deaths was much lesser than that. Okay, so per day you will have a statistics of what is your death and what is your number of cases. And now to plot it, it's a basic plotting, it's not a scatter plot also, it's a not a basic plotting it is. So where you are saying the figure size and all, and then you are saying that what to plot in the down x-axis, you are going to plot the date x label equal to date. If you see here x label, in the x-axis we are going to plot the x, and in the y-axis we are going to plot two things. One is the confirmed cases, date wise confirmed cases, and the date wise death cases. Okay, and this is my anyway the label of y-axis is the total confirmed cases and whatever you want, and this legend the location equal to true, it will give you this legend, I mean this confirmed and date. So let me just show you this, what is this legend will do. If I remove this line means just legend I'm commenting out. Okay, so now what will happen if I execute this one? So now can you see this legend is not coming? This legend is not, the legend is not coming. It is not showing me the confirmed and dead. So let me add the legend color, legend parameter here. So now you can see here it is showing that confirmed is shown with the red color and the death is shown with the blue color. Okay, so and where we are saying this show it with the red color and show it with the blue color, when you are plotting it in the y-axis, you are showing it here for the confirmed cases. You plot the total number of confirmed cases and you make it sure that the color is equal to red and it should have a label as confirmed. In the death cases, you are saying that the plot the total number of deaths and give the color as blue and label it with the deaths. Okay, and this labels will be shown if you use the command this legend. Okay, fine. I hope this much should be understandable. So if you execute this, you should be able to get this global graph date wise. Okay, let me just zoom it a little bit. So by the way, I'll request now everyone to do and check it out whether they're getting this graph or not. Let me see if there is any question in the chat section. Please check it out whether you're getting this graph. As of now, we are analyzing the current situation. I'm yet to use the FV profit model to to do the time series analysis. I mean, I have the data as of now to up to 18 June. I want to predict the future. I want to predict that, okay, I mean, what will be the next month? What will be the status? Like that, okay? So let me see the chat section. Okay, so some when group by date. Okay, what is that? 1 minute, 1 minute. Let me check it out. I think feedback link is fine. Prabhavati is facing some difficulty. Warnings are fine. Don't worry about the warnings. Warnings are fine, madam. It's not a difficulty. Can you explain? But change the group by option. Okay, what you have changed? Let me check it out, please. Wait 1 minute. One second. When grouped by date. Is it giving something wrong? Can you please unmute and say what Prabhavati? Top group by date, confirmed active. That's fine. Okay. Okay, I understand what you want to say. One second. So it is when you are, I think you are getting confused here. Let me just tell you. I think I'm getting what is a confusion. I think you want to point out here is a doubt here that why it is there are two things are written here, date and confirmed. That is absolutely okay, doesn't matter because you are group by, so you don't think that you are group by on multiple keys. Okay. It is not changing. If you, okay, fine. If you want to hear what we are doing, you are basically looking at these two columns, date and confirmed, and you are grouped by a particular date, that is grouped by a particular field, that is date. Okay, so whatever is coming as up in the parenthesis of group by command, that is only used for grouping. Okay, here this parameter, whatever you are seeing here. So okay, just let me do one thing. So if I just let me take something else. So if I just simply I'm writing, okay, so I'll say df dot, okay, so df, not df dot, I want to just, if you print this way, okay, this is the parameter of this. Okay, and let me execute this one. Okay, let me add a separate code only. Separate code section if I have to add, and let me just do a tk dot head, just adding the extra code. Once, and just let me get back what is the issue it is facing you, because it's a data frame. No, it's okay. Okay, 1 minute, let me see that what is the doubt Prabhavati madam is having, and let me get back to this. Afternoon session is then, maybe I can get back. I mean to say we can group by two variable. Yes, you can do. If you want to group by two variable, yes, you can do. In that case, if you want to group by two variable, then you are supposed to use it as an option of group by. You can group by two variable as well. Does it answer your question? Or I'm not answering, I'm not getting what is your question? Maybe you can unmute and say. Okay, let me just continue with the further analysis. Any doubt, whichever they have, they just message me in the chat section. I'll get back to this. Educator, what is the 1 minute? What is the issue? Okay, fine. I'll just get back to this. This anyway, I was just doing the extra coding, not required for now. Something key I have talked wrongly or what? I'll come back to this. First, okay. So as of now, we are here. Up to this, we are done. Correct? Okay. Now, similar way, if you want to know that what is the number of total top 20 countries having the most number of confirmed cases, you can do a group by country, and you can do a summation on the confirmed field, and you can sort the value with the in the descending order. So let me just check it one. If I do this, so what is that we want to do? We want to print the countries which is having the most number of cases, most number of confirmed cases. Basically, we have already counted the number of total confirmed cases per country. And what you have to do now, you have to print it in the ascending order or the descending order. Right now, if you mention as ascending equal to false, either you can mention as sort value, ascending equal to true or ascending equal to false. If I mention it as an ascending equal to false, means it will give me in the descending order. Okay, so if you just give it with just a head, it will print only 5 countries which is having the most number of COVID cases right now. If you want to print the 20 number of cases, 20 countries which is having the most cases, most number of confirmed cases, you can mention it as a parameter of head. So right now, if I mention is head as 20, it will give me all the countries which are having the more number of COVID cases. How many countries I'm going to get? I'm going to get the 20 number of countries. So you can understand that on up to the June, this is the situation. So on the June 18th, we had this situation where the US was suffering the most. US was having the maximum number of COVID cases. And then the fifth position, we had our country, India. Okay. So as of now, we are doing the current situation analysis all over the world. 2 visualization I've shown you. One visualization was according to the death rate. We have seen that which are the countries which are having
problem now. Wi-Fi ಇದು ತಗೊಂಡೋಗ್ಬೇಡ ಬೇಡ ಅಲ್ಲೇ
Prabhavati
ಅದು
madam,
ಇಲ್ಲೇ
request you to please mute yourself. Yeah, I feel it's done. Okay, so right now we know that so this is a current situation that which are the topmost country which is facing and all. So you can similar way you can print the top whatever I have shown you. This is just a number, right? All the numbers you can print it also with the bar chart or the scatter plot. Let me show this one. Here we are using the SNS library that we have used yesterday, that is Seabong library, and we are doing it with the bar plot, normal plot, scatter plot. So all the things. So what is the difference between bar plot? Bar plot is giving you this bars. Okay, if you want only the scatter plot will give you this points, and if I use just a plot command, then it is giving me this line. Okay, so right now you know that on that date, all the 20 countries which are having the most number of confirmed cases, the situation was like this. Qatar was having least, and whereas US was having the most. And here we have our country India, and down in the X label or in the X axis we have the number of confirmed cases. Okay, so these are just some of the visualization. Anyway, the graph is given to you. You can check it out. Okay, I'm not showing you all the other things. So if you by the just let me share it with you quickly because it is 12:38. I want to do one more topic, that is my with this COVID. Right now we are analyzing the current situation, how to predict the future. That is very important. Quickly, I'll just show you all the other graph. You can execute it. So if I want to know a per country situation, okay, I want to know the China, what is the situation? What I can do, I can extract out all the rows which has country as China. Okay, so that's what we are doing, right? Where the country is equal to China, extract all the rows and check out per date, group by you're doing of a per date, you're checking out what is active, confirmed, recovered cases. Okay, so this way you are predicting it for some particular countries on which you're interested. We have done it for China, followed by the same analysis is done for, let me check it out. Same analysis is done for Italy. I mean, the countries which were suffering a lot, that time China, Italy, India, followed by, here we have US, and here we have Germany. Okay, 5 country data we have now. So I have extracted the data separately of the 5 countries, which was the topmost country, 5 countries which are suffering, I should say. Now, if you want to check it out, what is the 5 country relative status, you can print it out here. Basically, we're printing, I'm not showing you all the commands, all the parameters, it's too tedious, but you can check it out. It's quite easier because you can see it as one parameter will be color, one parameter will be label and all. So print it out, it will give me this kind of color curve. Okay, so whereas, I mean, with the color coding has been done with respect to the different countries. Okay, so China means red color. Let me take example of two countries. China is a red color and the India is in the green color, correct? So let me see what is the situation. Whereas China was almost stable in this point. At one point of time, China's situation was almost stable. It was not increasing. But that time, our blue line or green line, I think green line was India. India was showing a sharp growth. Can you see here? Where China was almost stable at one point of time. All the, not only India, all the other countries are showing a steep growth. Whereas China, which started the situation, they were quite stable at this point of time. Okay, the number of cases were quite stable. So right, like this, you can do some country-wise analysis and check it out. So this will be helpful for any kind of data visualization if you want to do. Okay, so that's it up to this. I'll request everyone to finish it up to this code, and you should be able to get a graph like this, and you should be able to understand what is happening here. Please check it out if you're getting this graph or not, and any parameters. So I have not explained all these parameters. Okay, this is because it is like two. If I start explaining, it will be too boring. Okay, this scatter is for scatter plotting, plot is for line plotting. Okay, so if I'm using this scatter, because the scatter is used, all these points are plotted, and for plot command, these lines are plotted. Okay, so please check it out whether you are getting this graph. So as of now, we are done with the visualization. We have done 3 for visualization on a world map, some selected countries, how the situation is, worldwide, what is the death rate, worldwide, what is the number of confirmed cases. So please check it out whether you are getting this kind of graphs, bar graph, line graph, scatter plot, all the plots, if you're getting or not. Anyway, these codes will be with you. You can take your time to see, check it out, all the parameters. I request everyone to play a little bit with the parameters, change the color, change the X label, change the legend, change the location, see that how the things are varying. Maybe you can try loading some different data set. This data set was initial data set of COVID-19. You can check it out from Kaggle. You can download the current data set of today, and you can check it out how the graph is changing. By the way, all these dataset, COVID datasets are available with us. You can go to Kaggle World COVID data. Okay, so you can go to the worldwide COVID number of dataset. If you see here, this is a dataset. Okay, so go down. You can get this kind of data set, which will have the country or region, confirmed number of cases, death, recovery, and all. You can download this data set, and you can do your own analysis, and you can check it out whether you are getting this world meter data set will be useful for you. If you want to analyze only on the US, you can use this. Okay, whichever data you want. Okay, so I'll request everyone to please check, are you getting these graphs or not? If the question is if you can group by 2 variables, yes, you can group by 2 variables. Okay, so some person has told they're getting the graphs. I'll wait for one or two people more to check it out. And whether you have any doubts, you can. Jay sir is telling it's done. Now, what is the time? It's 12:44. Yeah, we have Ritvika. Ma'am, what does the reset index will start again the indexing from 0, 1. Otherwise, if you see here the output, I'll show you the index how it is shown. 1 second, let me go here. I'll show you 1 second. So whenever, okay, let me do one thing. So just let me remove this one. So if I remove the reset index, it is coming like this. If you give the reset index, it is doing the count properly, and this index is here. All the other values will not change. Let me go and show it. It is just how the index is started here. Index is 0, 1, 2, 3. Let me go up and show you 1 second. Everywhere the little reset index is given. Wherever I don't have reset index, maybe I can show you from there. So normally, basically this reset index is given here to print the index from 0, 1, 2, 3, 4 like this. So if you just
ಬರಬೇಡಿ ಅಂತಾನೆ ಹೇಳಿಲ್ವಾ ಅಲ್ಲಿ?
Maybe it's clear. Let me remove the recent index. If I do remove the recent index, that index was not coming. All the other values will be same only. Okay, all the values will be same. Nothing will change here. If you keep the reset index, it will come with a proper index, and that's it, nothing else. Okay, nobody's fine. So anything else from anyone? Or else I'll go to the forecasting one. So I'd request everyone to please play around with the code. You can change something, and instead of predicting, we are here, everything we're doing at summation, you can do a average case as a mean. So play around with it and see that how the code is changing. What is the implication? Okay, so if there is, I hope all of you are getting up to this graphs, worldwide graph. I mean the per 5 country graph. Now let me quickly show you. It's a very small code, not it's a very small code now. Now what do we want to do? We want to now let me zoom it a bit. Anyone wants me to wait? Code again in the chat section. Anyone wants me to wait? Can I continue? Fine, done. Okay, so right now we're interested in the forecasting the data. What does it mean? We have the data up to 18th June, correct? Now I want to know what will be my future status. Now in the future means you can, in the code, you can mention how many number of days you want to check out the data. So you can mention, if I mention the 365 as a parameter, then it will forecast me for the 365 number of days. So if I mention 7 as a parameter, then it will show me the forecast for the next 7 days or the next 1 week. Okay, so for that I'm going to use this FB profit model, which is, I mean, profit model FB for Facebook, which has been delivered by Facebook. It's open source model, which is going to be useful for the time series analysis. Any kind of code, any kind of application you have in which you want to do a future prediction given on the current data, you can use this model. That is my FB profit. Okay, so what you have to do by default in Colab, this FB profit model is not there. So you have to do this installation. Kindly do this pip install profit and pip install yfinance. Please execute these 2 commands so that this profit model gets loaded in your environment. Okay, I'm not executing this because I've already installed it. Okay, after you are done installing, then only you will be able to import this profit model. Okay, so let me import it from profit, import profit. So right now I've imported this profit model. Okay, now what I want to do, what is the data set I have now? I have the data set. This is my data set, country, date, confirmed, and all those. and this is starting data, and what is my ending data? As I have said, let me check what is the date. As of now, we have the data. Let me, instead of head, let me change it to tail. And yes, I have the data. As I have said, we have the data up to 18 June. Okay. Now we go down. Yeah. So now what I'm interested in, I want to filter out the data of India. I want to predict, I want to do a prediction. You may not do this, you may do the prediction of worldwide also, but right now whichever is coded, it is a prediction of only India. So here, as we have seen the previous coding also, how to filter per country wise. So here we are checking every data row, and wherever the country is equal to India, we are filtering it out. Okay, so let me check it out. What is this data set showing me? Yeah, so if you see here, it is showing me all the data in which the country is mentioned as India. Okay, and it is showing me the date situation of different days, that is by 22nd, 23rd, 24th, 25th, and 26th January. So this is starting, okay, ending it at the June. Now, if I go here, so right now, what do you want to do right now in this India data set? I want to do a group by summation of a particular date. Now that's what you should remember. As I have told, in this data set of this India data set, it is not that only India on 22nd of January will come only one time. It may come many times, because India on a particular date will be repeated for all the provinces which has given the data on that day. Okay, so now what you want to do a group by on date. On the India data, I want to know on a particular date India, how many confirmed cases were there. So that's what is done. Confirm.sum. It will give me, and this group by is done based on date. So on the date 26th of February, how many ever data has been reported from India? What is the total number of confirmed cases? Okay. So let me execute this one. So right now it is showing me on 22nd January, and January there was no COVID in our country. We started facing COVID from March, I think. Let me print tail. So yeah, so it is telling me giving me the data of the June, from 14 June to 18 June, we had around 3 lakh cases. Around 3 lakh cases we have confirmed, correct? Now, so, okay, now what I have to do, I have this data already. Now you have to use a FP model. What I want to do, I have the data of, let me tell you the objective. I have the data up to 18 June. I want to predict for the next 7 days. Okay, so for that, what I have to do, I have to use a model FP profit. Now, when you are using the FP profit model, it says it will work on 2 columns. FP profit model works on 2 columns. One column should have the name as DS. Okay, so DS is for data sample, I think, data sample or date sample, I think, and another is Y. Okay, so DS and Y. One is DS, another is Y. So what we have to do, not data sample. So DS is for date stamp. Sorry, DS is for this time series model. FE profit model works with 2 columns. One is DS. DS is date stamp, and another should be renamed as Y, which will contain the number for that particular day. Okay, so what I have to do right now, my columns are named as, this is specification of every profit model. Okay, by the way, so right now my columns are named as date and confirmed. Okay, to use my FP profit model, this date column has to be renamed as DS, and this confirmed column has to be renamed as Y. It is a specification from the FP profit model. Okay, so that's what has been done here. We have renamed the column names, nothing else. If you rename the column, let me see how it is showing you. Yeah, so you can see the same data as is being shown, only the column name has been changed. Okay, so right now I am compatible to load to use FA profit model. So what we are doing, we are using it. So here we are loading, building the model. We are using the model profit, and we have seen the interval width equal to 0.95. What does it indicate? It indicates a confidence interval. I hope all of us, we know the normal distribution and all of us, we know what does it mean by mass concept of confidence interval, correct? There will be upper limit and there will be a lower limit, correct? So this says that I want to predict with 95% of confidence interval. If you can say it also 80%, by default this profit model calculates it with the 80% confidence interval. Okay, here we have, you can manually change it also. So here we have changed predict the future with 95% of confidence interval. So let me execute this one. So my profit model is loaded now. The model is loaded. Now I have to connect my model with the data frame. So what is my data frame? So this is my data frame. This is what is my data frame, correct? Now what is the data frame name? Data frame name is confirmed. Okay, so now let me connect the model with the data frame. So this is my training step. That is my model dot fit for on confirmed. Okay, we are fitting the training the model on the confirmed data set. Okay, so now my training model is done. So let me execute this one. Now what I have to say, I have to say that how many days future I want to predict. Okay, so for that has been used a future dates equal to model dot make future data frame, and as parameter I have mentioned as period is equal to 7. 7 means I want to predict for 7 next days. So last date was my 18th June. If I mention as period is equal to 7 here, make future data frame means I want to predict for next 7 days. 7 is not mandatory. If you write it as period is equal to 365, then it will give you the prediction for next 1 year. Okay, now let me execute this one and let me see that what it is giving me. Future dates. So can you see that right now my future date is all the dates starting from after 18 June. After 18 June I have the data. Now it is starting from 19 June onwards to next 7 days. Okay, so now my data frame is done, date portion is done, but which is missing my forecasting, the prediction, what will be predicted value. So for that what I have to do, I have to predict. So for that you can use a model dot predict on future dates. Okay, forecast equal to model dot predict on future date and execute it. It is done, execution. And if you print it, it will print you 2-3 things. One is the future dates. Okay, so first one is the future date, next 7 days starting from 19th June to 25th June, all the dates are printed, and it will show you y hat. Y hat is a predicted value. Okay, so it is showing you on 19th June the value will be around 3,68,000 something, whereas the values are increasing continuously. So and on 25th June the value will be around 4,23,000. You can plot a nice graph with it. By the way, this is a predicted value. What is this lower and the upper? This is a confidence interval. If you, I think all of us, we understand math concept confidence interval. This is a lower limit and this is upper limit, and this is a middle predicted value. This is a predicted value and this is a upper and lower limit. So this y hat, if it varies also, it will be between this and this. This is a plus minus value upper and lower ranges given here. If you want to plot it, forecasting. So if you can plot it, it will show you an increasing curve. So I know the so forecast says that it will spread more. Okay, so that's it. It's a weekly analysis that is not required. I'm just leaving it off. I think it's almost 1 o'clock. So yeah, so it is all 12:58. So I'd request everyone to please execute up to this last 2 minutes are remaining. Please check it out whether you are getting the graphs or not. So as of now, today's first session, I have covered how we can execute, do the data analysis on the medical data set, and how we can infer that whether our disease is going to spread more or this is going to not spread more, or if it is spreading in whichever region. Okay. So, Madam Prabhavati, I request you to please mute yourself. I request everyone to please check it out. The code. This afternoon we'll do some other data analysis. Prabhavati madam, kindly mute yourself. Request everyone to please check whether they're getting the proper output or not. Any doubts for anyone? So as of now, whatever we have done that how we can check the disease current situation and we can predict the future with the FV forecast model or the FV profit model. I have covered the topic yesterday. We have covered the topic day before and yesterday we have covered the topic classification, followed by classification with neural network, followed by we have covered the time series analysis with the medical data set. So one person has told it's completed. So anyway, it's a lunch break. It's a 1 o'clock. I don't want to extend the session. So please check it out. If there is any doubt, you can. Kusuma, you want to cardio example. Okay, so what cardio example? So someone has messaged me that they want me to check the cardio example. So on cardio data analysis, what kind of analysis you want me to do? Can you just please suggest? I request the participants to please ask like this. It's good. So cardio example means what kind of data analysis you want me to do? Can you just say? Cardio angiogram data. Okay, so what we will do tomorrow, we'll do something with a cardio image analysis. That may not be actually directly a angiogram data. That will be image data of our heart, and with that we should be able to predict that whether the heart has some disease or not. So yesterday and all whatever we have done, we had the data as such, correct? So now with the image of a chest X-ray image, I should be able to find out where is my heart. And seeing that, I should be able to come out with some identification that whether a heart is having some disease or not. Okay, so we'll see how much can be done tomorrow. Full day, I'll try to do as much of image analysis as possible. Okay. So with this, I'll just like to end the situation, end this session, and again join back at 2 o'clock.
Thank you, ma'am. Thank you, ma'am. It was a very informative session. Now let us break for lunch, and we'll come back at 2 o'clock. Thank you, ma'am. Welcome back all the participants for the afternoon session. Welcome back, Antara ma'am. Hello.
Hello. Yeah.
Yeah, to you, ma'am.
Okay. So good afternoon, one and all. So with so welcome to welcome you all again for the afternoon session. So as of now, we are done with the disease detection with the data, followed by we have seen how to use classification, machine learning models, and the artificial neural network model. We have seen how to do the data visualization with respect to COVID data, and the same thing doesn't matter, same thing will be applicable to any other medical data also, and how you can predict the future, how you can use the Facebook profit model for the forecasting. With this introduction, so next what is the agenda to finish off my portion of this lecture is I'll be doing the image data analysis. I mean, so suppose we upload a chest X-ray image. We are not is that we upload. There will be a huge set of chest X-ray images are there. So we can train our model with those chest X-ray images, so that once our model reads it, it should be able to automatically say that whether this image belong to a normal chest, or they're infected with pneumonia, or they're infected with COVID-19. Similarly, they should be able to classify the lung tumor type, whether it is cancerous or not, or there are many more things you can do. Basically, you want to do now not only with the data, with the image, the data the analysis. Okay, so 2 projects we'll do tomorrow, but for that I want you to do some prerequisite. I want you to install, I don't know if you people have already installed it or not. You people are supposed to install Anaconda and Jupyter Notebook. So once you are installed it, you are supposed to get this Jupyter Notebook opened in your system. This should be Jupyter Notebook. The participants, please see to that you have installed Anaconda, and that is interface is your Jupyter Notebook. Okay, so I don't know for how many of you it's done. So take care. It should be done for tomorrow for everyone. So for now, I am not sure how many of you have already done it. And after you did it, you should see that whether it is working with a PyTorch. So I'll just, in the chat section, I'm just copying pasting a small part of code and check it whether it is working, whether you execute this code in the Jupyter Notebook, whether it is throwing you an error or not. If it is throwing you error, then there is some issue with that and you'll not be able to do the hands-on tomorrow. So I'm just, one second, where am I? Yeah, I'm just, oh, I have not shared my screen. No, sorry. I think it is showing. So what are you telling? Once you install Anaconda with Jupyter Notebook, this Jupyter Notebook screen should open for you, and in your browser, web browser, and local web browser. And once you execute, you can try executing this basic code imports and also check it out whether it is working or not. So if that, then you ensure that it is installed properly so that you can go ahead with the further data analysis. So let me go and just put it in the chat section. So kindly see to that before tomorrow 11:30 you have installed the Anaconda along with the Jupyter Notebook, and so that we can do some image analysis with it. Okay, so as of now, I think it is not done for most of you. So I won't be able to proceed with exactly the image analysis in that case. You can try doing it now. But by the time, whatever time we have, I'll show you what is the basics of data processing with the image data processing with your PyTorch. I mean, we should know what is the PyTorch, what is Keras, what is TensorFlow. Along with, we should know basically what is CNN. CNN, the full form is convolutional neural network. So what is it all about? Because tomorrow all the things we're going to use it. So tomorrow that much time won't be there for the explanation. So let me start the discussion on this, and after that I'll ask you people to do to a project with a very basic machine learning model you can use for doing the Parkinson disease detection. I'll ask you to do that work. And so let me first explain some prerequisite for tomorrow so that we can finish the things tomorrow and end. So first of all, we'll start with this. So just one second. So first of all, what is CNN? So by the way, before I started, can anyone of you explain what is CNN actually? CNN or convolutional neural network, which is needed for any kind of image classification, image processing in deep learning network? From anyone, any answer for CNN? What is CNN? Yesterday we did artificial neural network. Now what is CNN? Anyone with anything? Okay, so anyway, so let me show, no problem. Yeah, tomorrow once we start with our coding, it will be clear.
Pop quiz. What am I drawing? I'm going to make 3 predictions here. Firstly, you think I drew a house. You'd be right. Secondly, that just came.
By the way, is audio coming from the video?
Yes, ma'am. It's coming, ma'am.
Really easily to you. It was effortless. And thirdly, you're thinking that I'm not much of an artist. And you'd be right on all counts there. But how can we look at this set of geometric shapes and think, oh, house. If you live in a house, I bet it looks nothing like this. Well, that ability to perform object identification that comes so easily to us does not come so easily to a computer, but that is where we can apply something called convolutional neural networks to the problem. Now, a convolutional neural network, or a CNN, is an area of deep learning that specializes in pattern recognition. My name is Martin Keane, and I work in the IBM garage at IBM. Now, let's take a look at how CNN works at a high level. Well, let's break it down. CNN, convolutional neural network. Well, let's start with the artificial neural network part.
I think all of you remember artificial neural network, whichever we have discussed yesterday, right? We had one input layer in which a lot of neurons were there. And then we had an output layer. And in between, we said we have a lot of hidden layers. So yesterday, whatever we have coded, we had only one hidden layer, correct? One input layer, one output layer. That is anyway specific constant. And in between, we had only one hidden layer. ANN can have multiple hidden layers also. Now, let us see that what gets changed with CNN.
This is a standard network that consists of multiple layers that are interconnected, and each layer receives some input, transforms that input to something else, and passes it as output to the next layer. That's how neural networks work. And CNN is a particular part of the neural network, or a section of layers. Let's say it's these 3 layers here. And within these layers, we have something called filters. And it's the filters that perform the pattern recognition that CNN is so good at. So let's apply this to our house example. Now, if this house were an actual image, it would be a series of pixels, just like any image. And if we zoom in on a particular part of this house, let's say we zoom in around here, then we would get, well, the window. And what we're saying here is that a window consists of some perfectly straight lines. Almost perfectly straight lines. But you know, a window doesn't need to look like that. A window could equally kind of look like this, and we would still say it was a window. The cool thing about CNN is that using filters, CNN could also say that these 2 objects represent the same thing. The way they do that then is through the application of these filters. So let's take a look at how that works. Now, a filter is basically just a 3 by 3 block. And within that block, we can specify a pattern to look for. So we could say, let's look for a pattern like this, a right angle in our image. So what we do is we take this filter, and it's a 3x3 block here. We will analyze the equivalent 3x3 block up here as well. So we'll look at, first of all.
With this, I'll end this because it's a long video. I don't want to show you the entire thing. So mainly we should understand that CNN will have some applied filter with that, followed by whichever we have learned in ANN. Tomorrow when I'm doing the things, I'll give you a formal introduction of CNN as well. So followed by, I want you to have a look at whatever we are going to use tomorrow. What is PyTorch? And TensorFlow and Keras, yesterday I given you a very brief introduction. Let's see it a little bit more in details. And followed by, I'll leave you with, I'll ask you to do a project, because it is always like I'm doing something new. People are just copying and pasting the code. So it's better that we do something else in that case. Okay, so what we will do, okay, so by the way, I think I have shared the code with you. 1 minute. Give me 1 second time. Yeah. Okay, so day 3. This one I don't want to share it with now. I'm removing this one. Fine, so I'm done. Okay, so before I leave you with the project, so let's see that what is the other tool that we are going to use tomorrow. That is PyTorch, because the image analysis we are going to do with majorly with PyTorch.
This video explains the fundamental concepts behind deep learning and how tools like PyTorch enable developers to build and deploy AI. Deep learning represents a major paradigm shift from traditional software development models. Instead of having to write explicit top-down instructions for how software should behave, deep learning allows your software to generalize rules of operation from examples of correct behavior. This is important because deep learning enables you as developers to design programs that are defined by the data you have, not the rules you write. We're already seeing deep learning move out of research and be deployed at scale in production applications such as automotive, gaming, and healthcare, to power new experiences like autonomous vehicles, more competitive game opponents, and personalized treatments. Deep learning uses artificial neural networks, which are computing systems composed of many layers of interconnected units. By passing data through these interconnected units, a neural network is able to learn how to approximate the computations required to transform inputs into outputs. During the training process, the neural network adjusts its parameters to decrease the error and improve accuracy, effectively learning how to perform the task at hand. Thanks to techniques like backpropagation and stochastic gradient descent, we can accurately and efficiently compare and contrast the expected output.
One second, let me see. Someone is messaging something in the chat window. One second, just let me pause it. Okay, fine. Yeah, sorry. Yeah, I understand. No, we are just starting the discussion, and today we are just doing the basics of image processing with PyTorch. Okay, let me start it again with a discussion on PyTorch. So I have just introduced that what is CNN with a small video, and followed by we are discussing about what is PyTorch, followed by a little discussion on what is TensorFlow and what is Keras. Yesterday I've used the Keras and TensorFlow as such, and followed by we'll do I'll leave you with a project on the Parkinson disease detection with any machine learning model you can use. You can use your SVM or logistic regression, whichever I have told you, and to check it out whether whatever concept we have discussed as of now, whether you are being able to do it on any random medical data set or not. So I'll just tell you what to be done for that. And tomorrow I told that you're supposed to keep ready the installation of your Anaconda with the Jupyter notebook. And I have in the chat section, I have copied pasted one section of code, that should be working. Okay, and until analysis it is not working means your environment is not set up. So tomorrow you won't be able to do the hands-on with the image data. Okay, so that is why, because it was not ready, so I'm not doing the image data analysis today. That I will do 2 projects. I'll try to do 2 projects, morning one and the afternoon one. Okay, and that will end my portion for this workshop. Okay, so can you copy that again in the chat section? Yes, I should copy. 1 second, give me 1 minute time. So this is what, 1 second. Let me copy this one. Give me 1 second, sir. So Jupyter Note should be working, and this code should be working. Where I have the code. Yeah, we're not going to use Colab for this. We are supposed to use Jupyter Notebook for this. Okay, so but this code should be working in Jupyter Notebook, not in Colab. Okay. Instead Jupyter. Tomorrow we're not going to work with Colab. Now, so let's start with again the introduction of PyTorch.
Video explains the fundamental concepts behind deep learning and how tools like PyTorch enable developers to build and deploy AI. Deep learning represents a major paradigm shift from traditional software development models. Instead of having to write explicit
One. Just to quick check, is it X train? It is case sensitive. So you've written it as X in capital letter and Y in lowercase letter. No, it is not X in a lowercase letter. Just change that one. So model.fit, I'll just show you the code. So before model.fit, you're supposed to divide it. So just okay, let me execute it here. Describe it is done no for me. So dropping the column, you check it out. You've dropped the column or not, and then you print X and Y. So in that case, check it out. X should not have the name column or the status column, and your Y should have only the final column target or the status column. So Y is having here only the status column, which is with a 0 and 1. Okay, so you check it out whether you have the X with the 22 columns and Y with the only 1 column. Just check the number of columns, that should be sufficient. And followed by, you break it down in the training and the testing data. So I'm just training and testing data, I'm just breaking it off. So done, and then I'm trying to print X shape, all those, and so it will show you the I mean the training data set has been broken up in 2 parts. Training data, I mean the feature space will be broken up in 2 parts. Training will have the 156 rows and testing will have the 39 rows. Please, everyone can check their output with this, because right now all of you are using the same code and in the online environment and with the same data set. So this values should be same. It should not be different. So right now your training dataset will have 156 rows and the testing dataset will have 39, followed by you're supposed to use a standard scaler. Use a standard scaler, and then you fit the scaler with your training dataset, and followed by you transform your training and the testing data with the scalar function, and then print it out. So once I print it out, you should be able to see now all the data is there in the same range. After all the things are done, here you are supposed to load the SVM model with the linear kernel, and then you can use the model.fit xtrain ytrain, and it should give you some output like this. Just check it out. Whoever is not getting the output, please check it out from the beginning. If it may have happened, maybe the training and testing dataset is not divided properly, or some or the other reason will be there. I also removed outlets. Very good. The outlet removals is very good if it is done. So then it should not be a problem. I mean, anyway, it should not be a problem. predictive system is returning 0. Okay, so Ajay Babu has said predictive system is returning 0. So what you can do, sir, you to verify whether it should be 0 or 1, you don't give here any random value. You just open the data file and copy paste the values, the CSV values from any particular row, and check that row what is the status column, whether it is 0 or 1. If you're getting the same value, then it's correct. Ritvika madam, I'll request you to please do it from beginning once, and every step you see the number of columns, how much it is coming. If you remove the outliers, maybe your data point will get changed. I mean, the number of rows will get changed. And that's absolutely fine. That will not harm the model fitting in any way. Is it done, madam? Or still it is stuck? After removed outlier, it is rows with 1. All rows with or which field, madam's field? Which one is coming as 1? It should not happen. In that case, if it is happening that way, then you won't be able to do any prediction. There should be some 0. I think that is a problem. So outlier, how you removed? You just plot with a box plot, and you have seen there are some outliers like this. Okay, and so if that is the case, so what you can do actually for the outliers, there are 2 ways to do. One is that removal, okay? Another is outliers, you can replace the value of the outliers with the median value or the mean value. I think that is why the problem is happening. You can replace the outlier. It is not that always you have to remove. Yesterday I discussed that also, right? I showed the code only for the removal, but for the outliers, instead of removing, you can replace it with the median or the mean value. Okay, that discussion also we had. So I guess that is what is the problem. So if you don't have a proper balance, if there is a class imbalance is there, so that is what it is not predicting for you properly. Okay, it's already 4 o'clock. I'll not extend the session. So I'll request everyone to finish with this code. Anyway, code is there with you. Check it out if you're having any other doubts. Anyway, I'll be available tomorrow to discuss. So, and make sure that you install the Jupyter Notebook, okay, so that we can do it tomorrow. Okay. Okay, so I think Ajay Babu sir is writing something. 1 minute. The person doesn't have Parkinson. Okay, so 0 means it's correct, no? So 1 minute.
Madam, regarding Anaconda, Jupyter, which version we have to do, madam?
Come again, sir. Come again, sir.
Regarding Anaconda, Jupyter, which version we have to install?
You have to install it, sir.
Yes, madam. Which version? Any version or latest version?
Any?
Any version? Anaconda 2.0, Anaconda 1.3.
Latest one. The latest one.
Latest one, okay. And then you told another pyrotex something is what it is from?
No, I pasted some input. Yeah, this is what I've pasted there. I told you to check it that whether this imports are happening or not. It means that the installation is done properly, because it will have some dependencies that you are supposed to install. Okay, to make it work with PyTorch. You can see any tutorial for this in YouTube and all, how to set up the environment for to execute the PyTorch. Okay, execute with PyTorch framework.
Okay.
Okay, so now Ajay sir was asking something. 1 minute. The person does not have Parkinson's disease. User warning, X doesn't have any valid feature names, but standard scalar with feature. Once again, let me check it out. So it's done, I think, after that. So is it done for everyone now? Everyone has any doubts that I should answer?
But why does it say incomplete, like X does not have valid feature names, but...
Let me see. What is the issue? Let me execute it here. So right now there is a model. Let me see that what it is showing for me. 1 second. Accuracy score. Let me do it one by one, because if I miss the steps, no, it will not come.
Yes. Okay.
1 second. Accuracy. This is where we are building the model, and now we say, so this is what some value has been copied. So you can copy it from the data file. Okay, you copy it from your CSV file, any particular data file, and check it out what is the status value there. Okay, so that is what it should be done, and so that you can verify that your model is working properly or not. Don't give any random values. So now, so this is input data, and then NumPy array we have modified. Reshaping is done, fine. That then we have transformed the data, that is fine. Then for prediction, okay. Now let me check it out. What is the issue? If I execute it, it is showing me.
Yes.
Okay,
What
that
is
warning.
that? What means? Because we have given the final print statement has, but the person doesn't have Parkinson's disease.
Oh yeah, that is coming and 0 is coming, but with that some warning is throwing, right? Okay, let me check 1 second.
Yes, that is it. That's what I am asking.
Yeah, sure. 1 second, ma'am. X does not have valid feature names, but standard scalar was defeated. The feature names.
The feature names, because we scaled them and then we did some other things, and that is why it is showing that way.
The scalar is correctly loaded. This is the same scalar we have used for the scaling of the training and the testing dataset. That is correct. So, and if I look at this input data, here we need to do the scaling, because there are some value which is nearing 200, and there are some value which is there in the 10 to the power minus
as low as 0. Yes.
Yeah, so we should do the standard scaling. There is no doubt about it. So now why it is doing that error? Not error.
This much variation would not give a proper result, I guess.
No. Let me check it out. If we print, okay, let's print the standard data. Okay. Or let me do it in this way. Say standard data. Oh, there's only one row. No, fine. I can directly do it print. Don't print. Yeah, so now it's printing, so now you see the standard data, everything has come down to a similar stage. There is no 200. So your scaling is working here. Scaling is working properly for us. Okay.
Still, if the scaling is working, but still now you
user
got
warning.
that
Correct, is working. Yeah,
yes.
Warning. X doesn't have any.
Okay, fine.
I'll do one thing, madam. Yeah, that's better. I'll just check it out, and I'll just get back to you tomorrow. Okay. Okay. Fine.
No, this type of ambiguity should not be there, no? Or else we can correct the process in the beginning itself.
No, this is correct only. There is nothing wrong about it, madam.
But it is a user. As of now, the result may be correct. But that user warning, why is it so?
Yeah. That's what I have to just do a searching on it, and I'll get back to you. Fine.
Thank you, madam.
Yeah. Okay. Thanks everyone for joining. Tomorrow I'll just get back to with this one, why this warning is throwing, and we will discuss on the image data analysis. Okay. Thank you. Thanks a lot for joining.
Thank you, ma'am. The session was very informative. Thank you all participants for joining. So let us come back tomorrow morning at 10 o'clock. Thank you all.